And we'll get started back where we were. So I'm going to open up the file that we had yesterday. Telecat, all right. And this has to finish loading up some stuff in the background, so again, check till my mouse comes back. There we go. All right, so as a little short review, you can see from our little workflow toolbars here, again, the same, pretty much the same order and structure as you see on your takeoff menu, just choosing your course, but we've got these visibility toggles for existing, for design, for other, which is everything else. And again, we've got the color settings set from our settings, Carlson configure, takeoff site net settings, where we've enabled up here in this upper right-hand corner these the ability to show those particular things. So you can tell at a glance, regardless of which layer something might be on, whether it is meant for design or meant for existing or other, in which case it gets ignored. And so these things will actually go through and then read based on this assignment, the different layers for the two different conditions existing in design. And you can actually make another category besides existing design and other, like you might have one, there's this add target. And if you can add a target, you may call that, something like utilities. And you say, okay, and so now you see I've got a utilities tab and I can assign certain layers to that. Okay, so that's just some functionality and you can, do that as you need. I've never really come to need it, but, and then you can remove those particular ones. And you can't remove these existing design and others, just any new ones that you make. So you can make any number of those additional targets and sort of, keep them separated as you go along. Now, if we did that, I'll put that back for a minute here, and then, so now you've got those particular targets. Let's save and exit, and then if I go and look at my display options, you see it doesn't give me, so I've got display setup, contours, cut and fill label, cut and fill color map, but I've got basically I've got cut and fill as a category. I've got existing ground surface as a category. I've got design as a category. And then I have other. And this is that other, the built-in standard other. The one I just made called util, for utilities, it doesn't actually get something here that you can control it. All you can do is just sort of designate those layers to be on those surfaces, okay? So there's not a great deal of functionality with that other than just helping you clarify, and I'll actually take that one out. So, and there you can see a list of the ones you want to take out. So now it's back to where we were. All right. So once we've had that done, we saw we have a couple of prerequisites. You can't do anything without declaring a project boundary or a boundary polyline, that you have to have a closed polyline that represents the extents of where it's going to create the surface data when you create the surfaces. And those are things, and basically that's the workflow. And you can see from this project checklist, see, those are the different things from our typical workflow. We define the targets, then we set the boundary polyline. Both of those have been done. Make existing ground, make design ground. Now it tells me right now it needs to be updated because I've made some layer changes. I haven't really made changes, but it came up because I ran that define layer and then added the category and then took it away. So that it flagged it as a change. So then all we would do is simply go here and make our existing, make our design. And now if we go back to our project checklist, they're all done, and calculate total volumes, assuming something was changed. I'll go to the next one, and there's now my volume computations. Okay. And say the adjusted design surface, no. Okay, the reason that was because under total volumes, I had this balance cut and fill. All right, so that would be, that's an option for you. So if it's on, it will do it and then offer to save it. If it's off, then it won't. It will just run and tell you what it happens to be. Okay. So that's essentially the skeleton of this whole product. Now, what we have, however, are some additional things that we're going to get out of this that we can't get out of just simply computing a standard volume. We can actually assign materials and depths to anything on those existing and design layers. And so when it calculates the existing surface or the design surface, it will adjust those surfaces based on those depths that we give it. And those depths can include basically two categories: topsoil stripping or removal and replacement for design, stripping for existing, and subzone or subgrade adjustment, where we give the definition, we give the things that are on particular layers, we tell it, okay, on this layer, you're going to find some things and they have these materials and the depths are so far down to this particular, next layer of material. And we can name those, give them costs, give them different criteria for it to calculate. Say, well, when we do that, then that also makes those adjusted surfaces. And now we have three surfaces really that get built for each of those two conditions: existing surface and design surface. We've got the original unadjusted. That would be for the existing, the one called OG as a suffix. For our design surface, we have the one called BS, which is your basic top level, unadjusted design surface. All of the others, there's ones with ZE, which is your zone adjustment. That's the for existing, and ZN, which is your zone adjustment for your design. And then you've got an EX, which is the total adjustment, include both topsoil stripping and any subgrades for existing. And then you have an FN suffix, which is the final, FN final design grade. And by final, that doesn't mean it's the one that's the top surface of the finished grade. It means that's the final amount of adjustment that you're going to do to that surface. And if you were to look at that surface, then you would see all of those different adjustments. So that would be the one that you would put on a thumb drive and put on a piece of equipment to go out there and do your initial grading, so that you could then come back in and backfill with stone and different subgrade materials, sand, concrete, what have you, underneath your particular materials. So we've started to look at that with this defining the layers on our design tab. You see, we looked at the pad. Now that pad is the one the building is on. Now for any of these to work, and you can either hit the edit edit layer button up here, or you can just double click it. And for any of this information to work, and I'm just going to do a color, or just take it by default, whatever, instead of the texture. You tell it whether or not you want to include in the materials quantities reports. And then right here's where we've defined the different subgrades. We've given it a depth, and you have to make sure, and it's easy to miss, right here on the right-hand side, you have to tell it whether you're using feet or inches that define the depth. Otherwise, you'll, have a 20-foot deep subgrade underneath that building. So, but for any of those to react, even if we have a definition like this, if I've got other things drawn on that layer called pad that happen to not be closed polylines, then they won't get that subgrade calculation taken care of. So you have to make sure that everything that you assign a depth to, and this, again, you're assigning it to the entire layer, but everything on there that is going to get that depth of materials treatment has to be a closed polyline. And when I say closed, I don't mean simply this. If I draw, hang on a second, let me get out of this. If I draw, for instance, a 2D polyline, and I just go ding, 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 and ding, and I say finish. All right, so I've drawn what looks like a closed polyline. It is closed in the sense that it forms a closed figure. But if you look at it, if you select it and look at its properties, you see down here there is a property called whether or not it is closed, yes or no. So it is not closed. I would have to change that to yes to make it closed. And so there's another way when you're drawing these polylines. And I'll draw another one. There's one of the options is, and this is just true of any kind of drawing, if I don't have to go over here and snap to that endpoint and then say close it, I can just, where I'm ready to go to my last closing leg, one of my options down here on the command line is close. So if I choose that or just type C, it will close it, quit the command, and when you select it, you look and see that it is closed. Yes, it is closed. Now notice also, if I look in my vertex count here, there's my first vertex, second, third, fourth, fifth, and you'd expect there to be a sixth, but there's not. You see, when I cycle through, it goes from 5 to 1. So there's really only 1, 2, 3, 4, 5 vertices in this figure, even though it does say it's closed. If, however, I look at this one, remember, I drew it and then drew that last leg and snapped to that same vertex. And even if I go here later and change this to be, yes, it's closed, if you look at the vertex count here, I'm going to cycle through there. There's number 1, 2, 3, 4. Now, in this case, because I physically drew that edge over there instead of just typing close, there is a 5th vertex, and it is exactly the same vertex as number 1. So I go from 5. Now, when I hit next up here to go back to 1, the marker doesn't move, the numbers don't change because it's the same number. But this one has 5 vertices, whereas this one, which you'd think in that same condition would have 1, 2, 3, 4, 5, 6, but this one also only has 5 vertices. All right, so that's just some different behavior in terms of just CAD entities and CAD characteristics. But for anything on those layer definitions that you assign materials to and depth of material to, those things have to be physically closed. So if I want to take this outlined area that was my pavement around my parking lot, for instance, and I want to say that has a pavement thickness underneath it, I have to make sure that's closed. That's why I've got these little closing segments across these open ends, okay? I didn't close the concrete curbs, so that's just concrete, all right? And so this face of curb is that particular um, closed polyline, and it will be that material. And it does that material just like it does a hatch. So it will be that material from edge to edge unless something else in between interrupts it and has another type of material or maybe no material. For instance, that building has 8 inches of stone and 12 or 8 inches of concrete slab and 12 inches of stone. So that's what's under that area, but not what's under that part of the parking lot. It no longer will have. So it interrupts the material as it goes to the inside. So the only thing you need to really remember is that when you assign those materials, make sure they're closed polylines. You want to make sure you get the outermost edge of it to make that assignment. Now, if there are some other materials of the same on the same layer, which there will be. You see this selected, this layer is PR proposed curb FC. That's my face of curb. Well, I also have this one right here, which is also PR curb, face of curb. And also, I didn't make that one yet. I got this one. I'm missing one of these. All right, that's the face of curb. This other one's going to be my top of curb, but I didn't do the back of curb on that one for whatever reason, unless I put it on a different layer. All right, so these are all closed polylines, and I'm going to define each one of them as having pavement depth. But because this pavement depth starts out over here and it starts going and then it hits itself right here and that interrupts it. And then it comes back over here and leaves itself over here and starts up again. Okay, fine. And it comes over. Now it's back to having pavement depth. It's going to hit here and get interrupted and stop. And even if this inner border wasn't here, it would go across until it hit this building. Then it had a different set of materials. And that's what it would be assigned. Okay, so that's how that part works. You don't have to draw really convoluted edges. I do need, however, to right there's that back of curb, PR curb, back of curb. Well, that one works right. What is this one on? Top of curb. Top of curb. Okay, so I need to change all of these to be back of curb. I guess I neglected to do that part. All right, so I have it. Now let's get this one. It's top of curb, top of curb. That one's already back of curb. So I've got top of curb, top of curb, top of curb, top of curb, and those I need to change to be back of curb. And now turn that off. Now you don't see any backs of curbs, but if I go back to my, now this one is actually not back of the curb, that's actually on that design pad template, just happened to be in the same spot. But in here you don't you don't see those double lines. So what I need to do is go back to my define layers, go to other and find that proposed curb, back of curb, and move them to design. Okay, then now we see that's now there, back of curb, and we're going to save and exit. So now you see all of those now show up. Now I have actually physically changed my surface. So if I were to view the surface before I rebuild it, say design without subgrade, when I look at this, it does manage to grab the top. I don't think I've I don't think I ever unbuilt it. So let me just rebuild it. And now we'll view it again. And now it should be, now I've taken that material out. And now I can see the tops back of the curb. And there's that break line we put in. Now that break line we put in on this layer called pad, and there aren't any definitions for that. So even though we're going to have depths for different things here, let's look now with the subgrade. Design with subgrade. Now you'll see the building has been accommodated. Otherwise, remember the building was sitting at the same elevation as this pad around the outside edge of it. And there's a landscape island in here, again, at the same elevation that the building is, but there's no there's no subgrade to that landscape island. That would be a case where if this were a landscape island, then you normally would put, you would assign that as topsoil replacement. So it would show up in there, and it would take the thickness of the topsoil out of that because it knows that's what you're going to be putting back to bring it up to finished grade. Okay, so that would be typically how you would handle those. All right, so now you've done the, we've got the existing, we got the design, we've got our materials, volumes, we've got the materials signed for a building. So let's take a look and see about our parking lot, our asphalt over here. So I'm going to go back to my layer definition, go to design, and I'm going to assign these depths to this layer called face of curb. And that, remember, that's the line on the curb that is basically showing the edge of the asphalt. That's at the bottom of it before it climbs up to the top and shoots back to the back. So my face of curb, I'm going to double click. And the material name, I'll just call that park lot paving. You're just basically giving it a category here. And this time I want to see material type is going to be area. And if I know what that cost here, see, I don't have to define these thicknesses here. I can just give it a material and tell it that it's an area and tell it a cost per, whatever it happens to be, and not have to define these subgrades. So it doesn't change the actual elevations of it, but it accounts for the materials. So if I wasn't interested in accounting for how much sand and stone and coarse base asphalt and the finished coarse base asphalt, if I didn't have to make those distinctions here, And all I said was, all right, I've got paving in my parking lot, and I'll just maybe call it asphalt. And I know I've got to pay $17 a square yard for asphalt or whatever. I would do it there, tell it it's an area, give it $1 a cost here per whatever unit, and then leave these alone. But and then say, that'd be a situation like maybe I'm doing um, everything up to the edges, but somebody else is going to work on doing the parking lot. So I wouldn't necessarily worry about adjusting the grading to get down to the bottom of the subgrades that build the parking lot in that case. It's just going to give me a cost. So I'm going to pay, Joe Schmo's paving company, X number of dollars to pave this parking lot. And I don't care what it's made of or how deep he's got to go to dig it. That's on him. So that's how that part works if you just do it up here. However, we're going to give this some depth, and we're going to give it, say, an inch and a half. Now, notice I start typing in 1.5. Make sure you double check up here and switch to inches. So, well, not an inch and a half, but I'm going to call this my ID2 WC. That's my ID2 wearing course. That is asphalt, and that's going to be 1.5 inches. And we're going to say that's $17 a square yard, let's say. All right, so next depth, I've got under that top inch and a half, I've got an ID2 base course. And that's a coarser mix of asphalt, and that's going to be 2 inches. And that's going to be, say, $15 a square yard. And then I've got stone, or let's just call it number 2A. That wouldn't be 250, yeah, 2A. Let's just call it 2A stone. And we had, let's say, 8 inches of that. And that's, $65.75 a ton. Um, and that's limestone at 120 pounds per cubic feet. And then we maybe had just well-graded subgrade. We had um, a 12-inch. I had to cut down and then put back this 12 inches of compacted subgrade, and that was a $50 a cubic foot. What is it? $50 a cubic yard, let's say. So even though this asphalt has a depth, it always obviously has an area and it has a depth. So you could calculate a volume, but if you pay for it on an area basis, then you can put its cost basis in there accordingly. Okay. So I've got everything done here and defined. And again, these numbers, please forgive me. I know nothing about what it costs to do any of this stuff. Um, and let's give this a color. And we'll make it, say, this sort of gray looking. So when we see it in our views, we'll see it there. Okay. So now I've got 23 inches of subgrade material underneath the parking lot, all the way up to the top surface. Under my building pad, I've got 20 inches. And let's go with our building pad. Let's give that a color. And we'll make that sort of this 150. And until we got crushed aggregate and concrete, we'll say, okay, we'll save and exit. All right, so now I've made a change. So I'm going to remake my design. It's now been made. I'm going to now view the surface. And again, if I look at design without subgrading topsoil, all you see is the top surface. Now you see there's the top surface up to the bottom of the um, the bottom of the curb. Okay. Same thing, the building, you see, you don't see any depth because it's at the same elevation as the building pad around it. But if I do, though, view the surface and I want to see it with the subgrade or with subgrade and topsoil, I didn't do topsoil, so it won't be any different. But design with the subgrade, then when you look at it, you're going to see that additional depth. So there's now your 23 inches. And you can see how the 23 inches would be this gray, the green above it. Again, that's curb uh, material back here, but all this other is just green for assumed grass, I guess. And there's our building, 20 inches down below our building has that uh, cutout shown. And again, when you look at those quick profiles across the site, you'll see those little cutout zones for those. Now, if we're doing a building, for instance, right now it's basically a slab on grade, but let's say we have a basement under there that's, 10 feet deep. So if I go back to my layer definition, go to design, look for pad, I'm going to edit that. And I'm going to, instead of these, I actually want to put another say concrete's 8. I don't want it to be concrete. I'd like to be able to insert one. I think I'm going to have to do is copy and paste these down. So I'll copy and paste, copy and paste, copy and paste per ton, 125. This is going to be copy, paste, 8, 5750. Whoops. Per cubic yard. No density. Now right here, I may call this basement. All right, and I'm going to make that now again because I'm sitting with inches. Say if I'm at an 8-foot depth, then then I'm going to excuse me, then I'm going to say instead of 8 feet, I need to multiply that by 12. So that's going to be a 96-inch depth. And I'm not going to give it any cost. And it won't matter here. I can do it by just because square yard, it doesn't matter. I won't give it a cost, but I'm going to give it a depth. Now, right here are a couple of adjustments that you can make. You can adjust the target surface by the depth. So that's where you saw it cutting out those holes to adjust that target surface. If you don't want it to do that cutout, but you do want to accumulate your materials, you can uncheck that and it won't do the cutout. But there's also this guy right here. You can use a vertical from the pad to the surface. And if we do that, and let's leave that checked and say, oh, we'll say, okay, save and exit. And then let's rebuild. And then let's review. So there you see, I've put the basement in my building. and you saw the walls were vertical. Let's see if I want to go back to that again. So that's basically going a vertical slice straight up. So, however, if when you do this, let's say you want to actually account for, I'm going to go back to my definitions here under my pad. So let's say we're actually going to account for the cost of excavating that basement soil. And we'll just call that, instead of basement, we'll call it EXCAV maybe. 96 inches, and that's, I don't know, $25 a cubic yard to excavate. Now, instead of using the vertical from the pad to the surface, you could, use a layback. And you can give it a ratio. So if I use a 1-to-1 layback, what that means is it's going to dig down 8 feet, but it's going to lay back the sides coming out of the hole at a 1-to-1 slope. And so when I save and exit that, rebuild, there you see, now just you saw that show up just like we saw out here on our design pad template. In fact, it's using the same command structure to do that. So if I now view, you should see that layback slope from, where we come down to the bottom and then we lay back at 1-to-1 before we come out of it to the surface. Okay. So that's one way you can handle, um, deeper excavations, things like that. And of course, if we say, let's go back to it, pad, if I say do not adjust the target surface, save and exit, make it, view it, same one. You see, it didn't do the cut for us. It did, however, if we look at our materials, let's get our report here. I just do a standard report. It should be fine. All right, so you see it still accumulated all the materials for the building. There's my concrete and crushed aggregate, but it didn't, and up here they are in my costs, but it didn't actually adjust the surface. Okay, so it still accumulated the amounts. If I looked at my volume report, calculate my total volumes, see the existing source, update the existing, sure, it doesn't really need to be, I haven't really changed it. And when I look at that volume now, I've got a cut of 82, a fill of 16, 18. So I'm basically hauling out 6,600 yards of material. However, if I go back to my definition under pad and tell it to adjust the target surface by the depth, and let's even use the layback, we'll save, exit, remake, and then, oh, sorry, I hit the wrong one again. Design before adjustment, blah, 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 running triangulation file. And now look at my quantities. So these numbers should now be different. So you see now, if I dig that down, that's going to account for the amount of materials I have to take out underneath that building for an 8-foot deep basement and an 8-inch concrete slab and 12 inches of stone under that. Okay. Now, so that went from 6,000 up to 16,000. And you can see the difference as well. Let's go back to our definition. go to pad, and instead of using the layback, if we just use a vertical, save and exit, rebuild. Look at the volumes. No, I'm not going to update the existing. It's not changed. So now you see I've got 14,600. So it didn't account for the layback. It just went vertically up 8 feet. And of course, if we decide we're not using the basement, we can just take this business completely out. I don't think we have to move those up here. We'll see. I'll make and we'll say okay. And now we've got 8,000. So that would be basically 2,000 yards is accommodating those 20 inches of cut down. And back to viewing. You'll now see that is back into that 20-inch cut down depth to the base of that. That's basically the top of the subgrade around this entire site. We've done the asphalt, we've done the building, and then the rest of it is just, other adjustments. You could have these, let's see, we've got the back of curb, for instance. And now remember, the only one we have closed is the face of curb. So I've got this curb structure that walks around here, but it comes up here and dead ends and it's open. So it doesn't go any further. I haven't made closed polylines out of that. I could have, but then that would try to build a concrete curb across their parking lot. But what can we do for those instances where they're not closed? Because remember, I told you to use those materials, it has to be a closed polyline. So I'm going back to my definition, and this time let's use the back of the curb, and let's double click it. Now this time, this material name, I'm going to call conc curb, just so I can separate it out from the other concrete if I wanted. Otherwise, it would have added into the concrete. But let's just call it concrete curb. And in our material type, we're going to say it is the back of curb. Okay. And again, if I had a cost, I don't know what curbs cost. Let's call it $25 dollars a foot. Okay. But I have this curb dimensions. So I've got these 3 types I can choose from, type 1, 2, and 3. That's what you see here. So I've got a built-in uh, uh, curb and gutter, or I've got a deck curb, or I've got just a gutter curb, a little, well, it's a gutter and a wedge curb. So if I use this standard type 1, I'm going to use inches as my dimensions. If I've got curb and gutter here, let's see, what dimension would I have my top? I'm going to have a 5.95 because I'm going to have a 0.05 taper. So a 5.5, not quite as 6 inches. My taper is going to be 0.05. So that will give me from the taper plus the top should be my 6. There's 5.95, there's 0.5. My width is going to be 18 inches. That's the gutter width. That's fine there. My drop, let's give it just a 0.05 drop to pitch into the face of the curb. We'll call it a catch curb instead of a spill curb. My height, that's going to be 6 inches of material under the ground. My height 2 It's going to be 12 inches total, so it's going to go 6 up and then 6 inches of height. And that makes the base 24 inches. When you add all these things up, that's what it works. Here's my material is actually going to be concrete. And that has a cost of, let's say 1750. Now this, I'm defining the cost twice. And that's going to be per cubic yard. Okay, and you see this set button? If I choose set here, you see all these different things that have been created. Do those names look familiar to you? Those are the ones I've been typing in as we've been building these. So I'm actually building a materials library, and I can always use that from here. So instead of trying to remember that number, I can just hit that set button, go out here and find oh, there's concrete's 5750 a yard. All right, so I'll use that. So now it's pulled that back in here. Okay. So this, there's two different ways of doing the cost. And actually what we're going to do is if we look at a material cost report, you're going to see it doubled up. This is going to be the cost of the concrete that's going to build this curb as it accumulates around. However, if I don't define it here, I have up here defined it just as a length per foot basis, because that may be the way we pay for it. Maybe we're not ordering concrete to make curb because we're going to just have a curb machine out there and lay it down by the foot. So if we do it like that and say, okay, save and exit, make, and now, oops, discard perimeter polyline because it's not closed. Okay. That's right, it's not a closed polyline. Did it generate? Nothing there. Let's see our quantities. Again, that's just volumes. So let's look at our costs, our materials. I've got concrete curb. I've got five curbs, a total of 1,500 length. It's cost me $37,656 because I said that costs $25 per foot. So 25 times that would give us that. Now, in the concrete material here, I've got concrete under the building. That's the building slab. But that also I've got $3 billion worth of concrete. So I've got something goofy here. The concrete, I've got 6 at 54 million cubic yards of concrete. I think, let's see what we've done with it here. And go back to this building pad. Let's make sure we're in inches. Now that part's okay. There's my concrete. Let's go back to our back of curb. And let's go to our curb dimensions and let's rename that something different here and see. I think that's what blew it up, was because it's trying to make that into a closed figure to be able to use that instead of this linear. And then if I save, exit, make. See, it's still blowing up because it's not closed, which is okay. Look at our material reports. So I now have curb. All right, so that pulled that down. I've got something. That's blowing up the concrete. Well, it may be. I've got to move those up. Let's see. All right, let's just set concrete 8 inches. We'll set crushed aggregate 12 inches, and then we'll clear these. So that if this is the case, if this is what's making it blow up, then that's something learned. All right, so it didn't do the curb because it was closed. There you go. So apparently with that blank line above it, it just basically made it an infinite amount of concrete. So warning, it skipped 2 unclosed polylines for concrete curb. So the reason it did skip them in terms of going ahead and adjusting the surface, because we told it it's just a linear type accumulation. So we didn't close it. If we did close it, you wouldn't get the warning. Otherwise, the warning's there and it's okay. Oops, not pad, but back of curb. So these are not closed figures. These are just going to be this back of curb slash pavement type at a certain cost, curb dimensions, and there's that material. In fact, I can just, because I'm paying for it separately here and above, I'll take the costs out of here. So it's just going to be concrete curb. I won't see what used to have down in here, which said curb. So I should see a concrete curb separate from a concrete that I'm going to see in the building. And while we're here, let's make this color. Let's make it cyan, I guess. Say, okay, save, exit, make. Look at our reports. And so there's my concrete curb. That right there, that was where I took the material out. So it accumulated it, gave me basically the same numbers in terms of the length, but it actually computed the volume. So 69.5 cubic yards of concrete to make up 1,500 linear feet of concrete curb. But of course, we're paying for it by the linear foot, so that's where the cost line item is above. Okay. And then there now is my concrete for the building, which is separate. And you can see the cost basis on all these different ones down below here. And again, it gives you that little for the concrete curb. So it didn't compute that as a closed polyline with a depth. All right. So now to look at it, because we gave it a color, I want to see if it changes the color in our surface here. And I see that it actually, well, it did indeed. In fact, this is interesting. The back of the curb all around here, which did not close, okay? But in here, this one is closed. This one's closed. And in fact, the one that's all around the building part is closed. So it's actually treating all of this material in here as if it were that curb, as if it were that concrete. So that the way we would fix that, see if I can limit that. You see, because it was closed, it went all the way across until it hit something in its way. So I can either open that polyline, which would be what my initial thought would be. Let's see if it's got a particular depth. Well, it doesn't actually generate the curb structure. Let me take a look at the other view without the adjustment. In this case, see, I should see, and I don't. All I see is just that green undefined, and I don't see the wedge structure of the curb. Let me try this for an experiment. I'm going to go back to my definition, and I'm going to take out that face of curb. I'm going to move that back to other. Wait a minute. Back of curb. Oh, okay. Oh, I see. There's that. It's all right. So take my face of curb. You see what I had. This one. So if I move that back to other, I now have my back of curb. Is the only curb structure. So now the parking lot's going to go away. I'm trying to see if when it builds the surface, is it going to create the yeah, see, it does not, doesn't generate that the gutter pan where we told it the definition of our curb. That was my question. So it's basically just using it for accounting purposes. All right. So back to that definition that was our face of curb. And that's another question answered. when you move it from one to the other, it retains those definitions. So I'm going to put that back in design. So that's now that. I'll move that also to design. And now for the back of curb being, we'll say exit, we'll make it and where the 1, 2, 3 back of curb polylines, because they are closed, when you see them, you're going to see that show up on these inside parts, which basically is just the same as this face of curb does for the parking out here in the asphalt. So to fix that, I think, and this is going to be what I'm going to try, I've never actually run into this before, is if I take the ones that are closed and I'd go over here to the properties and make it unclosed. So I've selected that one and told it it's not closed. I'll select this one, which was also closed, and I'll say it is not closed. And then finally, this one in here is not closed. Now, remake. I should get more warnings. And let's look at the surface now. It's still treating it that way. If it's back of curb, let's see here, back of curb, including the reports, color, back of curb, type. Let me see here a minute. With back of curb pavement, the 3D polylines represent the back of curb elevations. When using this method, the curb polylines alone define the pavement areas, and no other design entities like design contours or spot elevations should be in the pavement area. The program will adjust the design surface for the height of the curb above the ground to get the elevations to the top of pavement. Also, with curb and pavement, the program will calculate your curb volume as well as act as the limit of the pavement. The pavement area is bounded by the curb polylines. The program will apply the subgrade depths defined separately from the curb dimensions. These pavement subgrade depths are defined. Okay, the pavement limit will be from the back of curb offset by the length of the curb base. In both cases, the base is 30 inches wide. Therefore, the pavement area will stop 30 inches before the back of curb. Okay. So, in this particular example, because we have defined the face of curb as our material for the parking lot. Now we did that to keep from having to put this closed off area across here to make that a closed polyline for the back of curb. So what we could have done is closed this back of curb line all the way around, all the way here, and it will take care of the paving based on the curb dimension. So if we did it that way, it would look like this. So these, the only line I need to define my parking area is this back of curb line. I'm going to take these two lines, excuse me, and move them over here to other. And now my back of curb is already defined by this as where the curb goes. And then I'm going to have within it, I've got my wear course, my base course, my 2A, my subgrade, in inches, 1.5 inches, 2 inches, 8 inches, 12 inches. All right. So back of curb will be the only one on there. So I'll save and exit. So now I need to find my back of curb lines, which are, there's that one. And that needs to connect across to there. So let me freeze that. There's my back of curb. So if I draw a 3D polyline on the back of curb, and I connect across the gap, and then I'm going to join nearest. What happened with this one here? Join nearest. There we go. Save my color. So that's now closed. I'm going to go back now and set this one, and this one to also be closed again. And now we make our design. We won't get the warnings. Let's see what it looks like. So there now defines the pavement. And it's supposed to stop it at the distance away. All right, so let's look at the other surface with the subgrade adjusted. Yeah, see, it's not picking up. Yeah, see, the only bit in here was that pavement part. And it's got a little gap right in there. Yeah, so I don't see that as a very viable approach to it. I understand what they're saying, but in this particular situation, I don't think it works very well in our favor. I think what we've done is we built our deck curb based on our lines. So I would go back to that original face of curb. Well, wait, before I do that, let me delete those segments so that they are no longer closed. I don't want my curb to go across. And now go back to my definitions. And I'm going to take my face of curb and my top of curb and move them to design. Let's double check here, my back of curb. It's going to just take the default here, curb dimensions. Well, if I'm using deck curbs, it would be a type 2. Top of 595, a taper, a drop, a base. Base would be 6. Height 212. So my drop, I've got a 0.05. Let's make that 0. Say, okay, now one thing you can do here, by the way, is if you define these curbs, see this save button, much like our other settings throughout all the software, you've got save and load. So you can save this and name these particular curb definitions and reuse them at some other point. All right, so now that's the back of curb, and it's just going to be this back of curb. So I'm going to clear this business. We'll take that out too. Let's see. Back of curb. All right, so there's that. Now the face of curb should be all our materials. There we go. We've got that. All right. So we'll remake, get the warnings. Now let's see. So now we pick up that, and we also pick up, because we kept that face of curb and we also added in the tops and backs, you see these little handicap ramps. That's we have to do it that way if we're going to use these differing pieces. If you try to use that back of curb linear feature as everything that defines the parking lot, you won't get those little controls like this depressed curb. You would only get edge to edge. All right, so let's see what our materials are. Concrete curb, concrete. So 1506, total length of concrete curb. 1506. Well, instead of remembering that, let's just dump it in our screen here. Yeah, that's not. There's a look for. Monochrome. All right. So now 1506. All right. So what I want to do next is to isolate that back of curb layer. And I want to look at these numbers. Oh, excuse me. I'm so sorry. All right. So I'm doing this to check here. So I've got 81.7. Comparing this with the report. Oh, excuse me. So sorry. And there is 104.4 and 1320.2, 1320.2. And then finally, or not finally, but 572, 572. And now finally, 1197, 1197. Yeah, see, that's 3,275. Did I do that right? Let's see, there's 81, 104, 1320, 572. All right, so 1196, 1197. Take that back out of the picture. And 572, take that out of the picture. Yeah, there's your 1506.03. So when it gave you the warning that it discarded these non-closed polylines, it did not accumulate that distance. Okay. So here's a case of if you don't have these as closed figures, they don't, excuse me, they don't actually accumulate that length. So the only way around that in this case is if you wanted to keep that open, for instance, is you'd have to close this, calculate your totals, take that report, and then figure out what that width is across your entrances and take that out of the total linear footage for the curbing. Or do like what we're doing right here and just add up all of the linear distances for this and put that in your spreadsheet and say that's how many feet of curb I've got. Okay, so that's one of the sort of limitations that it's got in accumulating these materials is that when it gives you the warning, now it did give us some numbers. But remember what it did was it gave us the numbers only for these three things because those were closed. That was our 1,506 linear feet. When it gave us the warning, because it warned us at one point here and at one point here because they were not closed, then it totally disregarded all of that distance out there. Um, and it's not it's not as if, let's see, if I did this, called it closed like we did before, and then recalculated it, it would accumulate those. And we could still have the face of curb be in the pavement definition and still keep the face of curb in the surface calculation for the curb structure as it goes around. I'm just trying to think of the best approach to doing that. That would be probably what I would still do. So to be able to still use those depressed curbs, because we separated the three curb lines into separate layers. We've defined the face of curb layers, and that is a series of closed polylines. That controls the actual pavement, okay? Whereas this being a back of curb slash pavement type thing, with this, we would have to actually close. So if I go from there to there, and there to there, join, it's now closed. Restore our layers, remake. And it's going to give me a problem here. What? Oh, yeah, there's the back of the curb. So what I would do, actually, what I would do here is isolate these two layer lines, or two curb lines, the back of curb and the face of curb. And I would take this line to keep that from crossing from happen. I'm going to insert a vertex in that line to right there. Let's go up to there. Put this one there. Okay. And then up here, that should be okay as is. Let's restore. We rebuild. Still getting a problem. Oh, I see. So we're coming off of here. Let's go all the way down to the surface. And then this is going to cross as well. So we need to add all the way out to there. Yeah, that should do it. If not, we'll just ignore. All right, let's restore, make. Eh, what do we got now? Ah, okay. Because one crosses over the other. All right, so we'll just exit that, but I want to look at the materials now. So now my concrete curbs, I've got 3,330 total linear feet. And that's what I had when I added up all of the linear footage, plus a little bit extra, the width of the drive aisle. So that's the that's the trade-off. There's no accounting for that as a linear feature. It still has to be a closed polyline. However, we, because of still keeping those other features in the mix, we were able to, um, yeah, now you see the curbs are showing up. You see that curb cut out? So there's the back of the curb. So it made the erroneous assumption to cut that down into this part. So yeah, that's a bit of a dilemma and bit of a trade-off to try to get it. So what I would do, Jack, in this regard, because the intent of that switch when you are using the back of curb as a linear feature, the intent of that is to let that define the pavement between all of the edges of the backs of curbs. But in our case, because we have depressed curbs and we're changing different things, we can't really do that. So what we did was to close off the um, the back of curb feature, make that a closed polyline also, and then it tried to do that. It tried to put the stamp down into the surface for that curb geometry. Remember, we changed it to the deck curb. So that's what you're seeing there is that impression of the deck curb punching down into that. So if you put the concrete curb back in the place of that little ledge, it will fill it up to the top. So that part works okay there, but we don't then get to take advantage of what we did the first time of using the individual curb faces and using the one that was our face of curb to control the pavement and use the other two lines simply to help refine the elevations of the design surface that which gives us then those curb depressions and variations accordingly. Plus, if we had other line work like contours, or maybe we had some 3D break lines. In fact, as you saw back here where we put in this 3D break line, see that's, if you just rely on the back of curb to do it and you don't define this one as part of that design surface, it won't push this pavement down. it'll probably just give us an error because it's trying to go from back of curb all the way across to the next back of curb to define the pavement. So unless they're just for very simple parking lots, and this is, pretty complex. We've got an outer ring, an inner ring interrupted by two additional inner rings. So my recommendation on all of that, let's select this report. I don't need that anymore. Let's go back to our definition. Let's go to our design. Let's take our back of curb. I'm going to double click that. I'm not going to include that in the report. It can be whatever. You can have certain things that are just counts. Um, but it won't make any difference here. So it's no longer there. The face of curb governs the pavement. The back of curb is just going to be used to define the ground. We'll save, we'll exit. Let me now isolate and revise that. I need to get rid of this stuff, so I'm going to delete those segments. Then I can get rid of that in its entirety. Do the same thing over here. Get rid of these segments. Uh-oh, wrong one. There we go. Make sure there's only two. There's only two. Okay. Restore my layers. Save my drawing while I'm at it. Let's make design. So now I won't get the errors. And then when we look at our materials, you're not going to see the curbs accumulated in the materials. So what you would need to do is understand when you're putting this together as a cost estimate or whatever, you would run this scenario and you would make a note to yourself that you need to, all right, put that, and you can exit those, by the way. If I look at this in, let's look at my details, report. Um, so you can actually not only get, here's a more detailed listing, but you could also then spread, kick that out to a spreadsheet and actually export that to Excel or what have you. And so what I would do in that regard is to run the materials. You got the materials for all the other things, but you now need to account for the curbs. So then you would go through and isolate the layer that those things are on, just add up their lengths and put them in manually to your spreadsheet. I don't know that. Let me see. If I do parameters, I don't need that tons. All right, so if I do this by selected entities, there's 1, 2, 3. And now I need this last one here. Make sure I get the back of curb. Didn't give me anything. Selected entities. Okay, select the materials or select the entities. Back of curb. Yeah, I think it's just going to be easier to simply grab them and look at their CAD properties. Yeah, see, it doesn't identify them at all. Let's do the face of curb, see if there's a problem with, yeah, it's because those weren't closed. So, or actually not because they weren't closed, but because they weren't, back of curb. Let's do back of curb, $25 curb dimensions. Yeah, we'll call it good. Call that good. Save, exit. Run the report. 2 warnings. I'm trying to see if this is going to actually help us get that individually. I don't think so, because I think it throws away those outside ones. So if I do this instead of the entire drawing, let's just do selected entities. And I want to grab the backs of curbs. So there's the back of curb there, back of curb here, back of curb here, back of curb here, and then finally the back of curb here. Yeah, see, because those were not closed. So let's not get the 2 outside ones. Let's just see if it will pick these up. That one, that one, that one. Oh, even that's not giving any materials. Did I save the definition? Ah, daggone it. Include in the report. That's what I didn't do. So say, okay, save, exit, make it. It gives us the warnings. We'll do our report, selected entities. That one, that one, that one, that one, and that one. Yeah, it still only gives the total perimeter of the 1506. In fact, see this double business here is because of that curb definition. Yeah, so again, what I would do is just not really define anything as the back of curb. So let's take that out. We won't include it. It's an area, it's not a curb. We will just say, okay, save, exit. So it's now really not defined. Make. So there's our parking lot and our building. Yeah, so I would do it that way and then go through and just add up the perimeters if you need to get a length of curb structure to pay for that separately. If I look at, let's look at a cost summary report. cut and fill, import, and then the materials. $718,000 for materials. And again, remember my cost numbers. I have no idea. Um, so, so take all those numbers with a grain of salt. Okay. All right. So that puts us about 15 minutes late getting to our morning break. So at least we're not an hour and 15 minutes late. So I'm going to call us our break. We'll come back at 11 o'clock. Any questions on this part so far? You've seen some of the warts now, where it's not going to be, it's not push button foolproof. And you have to sort of think your way through this and do some gut checks on this to make sure, like adding up those distances to see if that made sense. And you see it didn't. But once you're familiar with it and if things pass the sniff test, then you can really go to town and use that to help you accumulate costs and estimates and material quantities and that sort of thing. Okay. So let's see. Sorry, I had my stupid chat window was off. Let's see what's the shrink factor in the curve. Okay, no, that wasn't a shrink factor. So many digits to couldn't. Yeah. Okay, so you got everything good to go. All right, I'll see you back here at 11 o'clock, sir. I'll pause our recording. Recording. All right, so uh, you've seen sort of, like I said, some of the warts where you have to understand what's going on, do a little digging to make sure it's reporting what it is you expect. And we saw where we had a bit of a conflict on that curb issue. And it would be a trade-off. You could do one versus, one approach versus the other. Do one approach and you can lose the subtleties like with the depressed curb areas, or you can do the approach that we did where we defined the pavement within the actual face of curb, but then we have to account for the curbing separately outside of this process. So regardless, it does honor the fact that they have to be closed polylines. Now, you notice they did help to define the surface. So their elevations, even though they're not closed, were used. It's just the material assignments that have to be on the closed polylines. All that other stuff is just like building the surface, points, um, line work, any of that kind of stuff still holds for surfaces. Now, I also mentioned yesterday toward the end of the day that you could, like I said, we built these uh, existing and design based on these layer assignments. And one of the options that we can use instead of using this by layers is we could choose a specific file. Now, what I'm going to do is this. I'm going to build this surface here, but I'm going to raise this guy up. So I'm going to raise him up to 8, just make it 820. So a foot, 1.3 feet higher. Now, when I do that, I'm going to make an independent surface now. And I'm going to say, I'm going to turn on that so that I get that particular, don't need that anymore, but I do need this PR outside pad. So I'm going to turn that back off and we'll do that proposed outside pad. let's do this. No, that's not the one I wanted. Let's see. Oh, see topo circ boundary. Sorry, that's why. So if I turn on that boundary layer, just the boundary layer, so I can pick it. Now I'm going to build an independent surface separate from the takeoff way. I'm going to say triangulate and contour. And I'm going to write this file, and I'm going to call this my demo one specific file, specific FG file. Okay, I will use inclusion, exclusion area, identify my break lines. I'm not going to contour it. Okay, no filters. All right, I'll say okay. Select the inclusion polyline. There's that one. And now select the entities will be everything except that guy. So I didn't get that guy included. All right, so that should be that. And enter. And now when I view that file in my standard file viewer, there's my where am I? Triangulate and contour. Can you start demo one specific FG files? Okay. Okay. Oh, I know what I did. Sorry. So pick that as my boundary. No exclusions. Now, there we go. So now when I look at that specific file, you're going to see that area in the front, you see, is raised up. See how it's higher than the building? Okay, now, when I go back here to my takeoff method, I still have this design pad, but I'm going to change this surface source from layers to file. And I'm going to select that file. So there's my demo one specific files open. I'll save that. Now notice we still have these definitions in here. So, and I'm going to put this back to the same elevation as this one. So I'm going to go to elevate, change elevations, absolute. We will select the building and then select that pad. So I look at that and it's now back to 818.7. All right, so if I were to rebuild this, first of all, let's view the design. No, that's that last one that we did back when we were just layer based. I made a new one and I told it to use that specific file, but I haven't made the design surface yet. So if I make the design surface, it should, and this is what I'm trying to figure out, it should honor that other file, which will bring this up higher. And indeed it did. You see, it's sitting up higher than the other, but it also if we look at it with the subgrades taken out, it also applies those things in the layer list with their depth of materials. So if you want to, if you get a situation where you want to make the basic top of the surface based on running triangulate and contour from the surface menu as a specific file, which is what we did when we raised this up. And even though we've now put it back down and we saved the surface, it doesn't compute the surface from these entities anymore. It looks at this file that we made as the surface, and then it looks to these to simply apply the subgrade depths and such too. Okay, and then, so it still makes, excuse me, it still makes, if I look at just standard surface file viewer, this file that we made specifically, it still makes these demo one BS. See, that file should be the same as that file. So if I open that, you should see it with the raised, which it is. And if I look at it as demo one with the zones applied, again, there it is. And again, with that raised area in this part where that landscape area is. So it takes that specific file that we told it about down here as our starting point, and then it uses this information to apply the subgrades into those specifically named files. Now, if you notice, if I go to view with my standard surface file viewer, I've got this file here that's 3.2 megabytes in size. But the identical file, this demo one BS, is only 500K. So it makes a more efficient file because it's thinning out the surface. It's throwing away extra stuff we don't really need. So it's a little bit more efficient in that regard, but it lets you also really get fine-tuned on the actual definition of the surface and then use this layer list to simply apply your materials either way. But you could, like we've been doing, simply let it build the surface each time. And now if I go back and make that surface, you'll see that central area will now be suppressed back down to the same level. So there you see it's back down to that same level. Okay. So don't lose sight of the fact that you can build these surfaces independently of each other. Like for instance, we could have a big graded site and then we could have a roadway, let's say with, complete with, and we go to roads and we do, road network, and we do a design template on the road, just like we would have done in civil, and create a roadway through, so, and then merge those two files together and make that our base, or make that our definition of what to use down here. And once we do that, then we could then come along and apply materials to those surfaces. And it still makes the 6 named surfaces, which is the same name as a drawing file name, with those suffixes on them to make those adjustments. All right, so that's sort of a tool with a little bit more finesse to it. So you can do all kinds of modifications and stuff getting the base surface ready. So once you've got the actual top surface done, then you could go back and start to apply the materials to that surface. All right, follow that. Does that make sense for you? Okay, good deals. All right, so what other things can we take a look at here? If we, let me close off of that. We go back to our takeoff menu. We've got, some things we set the boundaries. We looked at that. These subgrade areas. Right now, we've got some tools here that can help us define. What I've been doing is just like popping into this view. Here's design with subgrades so that I can see, what gets uh, applied to verify. So here I've got my pavement, you see, and my building. Those are the only two things that have subgrades. Everything else is just this grass area. Um, so you could have, let's see, what was this on? This was on proposed LCST. So if I choose that proposed LCST, which I'll call my landscape area, I could now say I've got, stone, let's just call it pavers. This little 4 inch, well, let's make them 2 inch pavers. Oops, let's make it inches. $25 a square yard, who knows? Um, and then we had, let's see, number 57 stone, 4 inches as a drainage layer, $15 a ton, 120 pounds per cubic foot. And let's say, we had a sand layer as a leveler course, like 6 inches of sand. I have no idea. Let's call it $10 a square yard. All right, save and exit. We remake our design. Now, if we build or if we view with the subgrades, now you'll see that part has now changed. I didn't assign a color to it. Guess I could have done that. What's my design? And let's give it a color of something that looks sort of sand-like. Save, exit, make, and then view. There you go. Now you can see that was, and if you were to go out there and measure that, you would see that difference is, what do we call it? 2 inches, then 4 inches and 6 inches, whatever that total was. Okay, so that's one way we could verify it, but there's other things too. If you're curious about, how these inner outer closed boundaries will affect your subgrades, on the takeoff menu, you've got the subgrade areas, and you can do things like hatching. So if you hatch your subgrade areas, for instance, let's hatch just the building. We'll draw it, and we'll make it red with that cross hatch, and it's going to look like that. A little different scale. All right, you can go back to that subgrade areas. You can erase it. You can actually draw them all. And you could assign them as different colors and scales and such. We can, let's erase the hatches. If we did them individually, hatch the subgrade areas, there's our building, parking lot. Instead of red, let's make that this color. Repeat the command, subgrade areas, hatch subgrade areas to do our building. That should have kept the red, it did. And then subgrade areas, hatch it again, choose the landscaping, draw that, change its color again to something like that. Okay, so now you can do those like so. You could then also look at the subgrade areas. You can, again, hatch and erase. You can draw a legend and fill out the labels and the sizes and all that kind of stuff. We just pick a position over here. And okay, so we need to move all of that stuff, right click, move, just drag them up here. So you can use that. Let's see, let's change our text style. Text, set style. That was standard. Let's make that something pleasant. So there's a little legend. You could also label the areas. And let's say you only wanted to label, say, the building. Give it a size, label the depth. Sure, let's do that. Label the area, might as well. And so now that puts a little label on what's in the building. So 20 inches for building subgrades, and there's the area in square feet. And you could do that for each of those individually or all together. And then you can erase the labels, erase the hatching. But this is a good way to verify and just show you, instead of looking at the actual surface to do that, you can actually make a little plot of this. And that's what, if you remember from some of these sample projects that I showed you, we had Carlson projects. Yeah, our Guardian. See if we have. Here we go. This, for instance, this was our topsoil stripping area. So that's exactly what I did for that, and then just plotted it to a PDF file. Okay, so that showed, that was part of my report for the client, just to show these different areas. And, and that was done with exactly this tool. So I did the cross hatching, and then I just plotted that out to a sheet on a PDF file. All right, and again, you can take those out. Let's erase the hatches. And let's erase the labels. We can't erase the legend as a separate item, but you can just simply select everything and delete it. Okay, so that similar thing can be done now. Again, I hope you're getting the sense that we've got certain certain area or certain things that we look at and report on are done with these closed polyline boundaries. And so you can do certain things with that. We have these areas of interest. Okay, so we can draw areas of interest. Now, what is an area of interest? And it's just nothing more than something you want to anticipate. So if we had, for instance, I'm just going to draw a rectangle. I'm going to draw, let me set on a label or set on a layer. Let's make a layer here. Or let's just choose draw 2D polyline. And I'm going to uncheck this and I'm going to put it on a layer here called area of interest, which we can change and set the color and all that kind of stuff later. We'll just make it by layer, say okay. And now if I want to do this area of interest, let's say, let's go say from here to here, here. And then we'll do another one. And let's see, let's make this one from here to here. And we'll do one more or two more here. We're going to go from, we're going to follow this guy and we're going to start right here. And we're not going to interpolate the elevations and we're going to go up to right there and we'll come down to, yeah, let's just get the midpoint here. Not really there, but let's say, let's go back to follow again. We'll follow this. We'll start right in there and we'll come out to here and then let's close. Okay, first of all, these are not closed. I realized I need to make them close. So that one's closed. And then if we did one more, we'll start there, go to there, go to there, go to there, and then we'll close. All right. So now we've got some areas of interest. And if we go down to our areas of interest and we want to tag these areas of interest. So I choose that. It says select the area of interest, inclusion, perimeter, polyline. So that would be this one. Now they can be more than one, but we'll just call that one. And we'll call that area name. That might be our phase one. Set any exclusions? No. So again, you could cut little holes in these if you wanted. So that was phase one. We'll do this one as phase two. No exclusions. Do it again. Call that one phase three. And one more time, we'll set this one as phase four, but we'll make an exclusion of that little landscape island. Oh, when exclusion is outside the inclusion. Okay, so it has to be completely inside it. All right, so now, like we did with the subgrades, you can also look at these, hatch the areas of interest. Let's look for, let's see, cycle different colors for each. All right, so there you see, it gave me a warning that it was outside, but it did go ahead and cut out that part for phase one, phase two, phase three, phase four. Again, you could draw legends, you could label, you can do different things. Now, what good is that So I'm going to now erase the hatches. There we go. So, what is it we're doing here is we can, let's see, identify, report the areas. And there's the different areas that we've got. Phase 4 exclusion, it read that part of that from that list of areas. But where this comes into play now is when you run your reports. If I do a standard volume, and we don't have that for, you see how it flipped through and found these different areas of interest? So now it gives me my totals and all of that stuff up here is my export volume right here. But now within my areas of interest, it tells me how much I've got. So here's for phase 1. Down here's for phase 2. So it subtotals and subdivides all of that information, not just the volumes, but also the materials. It should. This is just a standard summary. If I exit that and do a, let me see, was there anything here? Oh, use areas of interest to report materials. There we go. That's what I wanted to look at. And we'll say, okay. And now here's their areas and their total breakouts of the different totals. What did it have? All right, so with the summary, it doesn't bother with that, but if I use these in detail, let's see what that gives us. So we've got, here's our building subgrades. There's our total. There's our parking lot paving. All right, I'm not seeing it. If I add my area name, let's move that up. And let's do subtotals here. Area name and materials. All right, so now there's phase 1 materials, total, subtotal for phase 1. And then we have our phase 2 materials as it applies there. And then phase 3 and phase 4 finally to conclude. And then the grand totals at the bottom. Okay, so I don't know why this one did not use areas to report materials. Okay. Limit quantities by boundary. No need for that. Report by materials. Report by layer. Yeah, it should have included those here, and I'm not sure. Does yours, like if you're following along, do you, if you run that, if you've made these different sub areas and you run that or materials report, do you get numbers in here from the summary report? Because all it did was tell me the different phases, but then see, that's supposed to be subtotals here. But I don't see it broken out by those phase boundaries. All right, so it's not something that they broke in recent versions. That's supposed to work there, and it doesn't. You'd have to go to the custom report to get that one. We've got a cost summary report. And it's just a do it plan view. Couldn't be open because you don't have permission to view it. Okay, that's fine. In which case, what it should have shown us was, let's go back to our getting started. I don't know where that did it. That that command should have given me a PDF. Huh, yeah. I don't really see that here, but it basically that command where it says plan view, that just zooms in, makes a plot on a PDF. But now, so a couple of other ways that we can look at this. You can run some cross sections, for instance, if we do left to right, bottom to top along a polyline. So let's do it along a polyline. And we're going to, let's just strike a line across. So if I draw a polyline, we'll put this on a layer called cross sections. And let's go across their site, including that little landscape area that way. All right, and then if we look at our cross sections along a polyline, design with the subgrade. There's no topsoil, so that would be with the subgrade, and then the original ground. Station interval, let's go every 20 feet. So there's the line that we want to look at. And let's see if we can make this just a standard 1x1. And you can set up grids and labels and all kinds of things that you, and you save and load those settings. Let's just take a look at the defaults and see what it looks like. Create original ground profile. Okay. That should have been that. Let's see now. Let's look at our cross sections. it should have come from, do that cross section. Cross section report along a profile. Design with subgrade and original ground. We're going to go every 20 feet. Select the center line. All right, so let's see if we can find out where it put this. Station to draw, let's draw all. Let's do 11 by 17 here and look at that and see. All right. Then let's see if it created sort this by date created. It's not. Where did it find it? Sort by name. Demo 1. Cost data. I should see section files. I don't. Huh. Let's see where that's supposed to go here a minute. Let's go Carlson construction. Take off graphic reports, which was a cross section. Don't see it. Should be here. That's just giving us that one menu, the takeoff menu. Let's see if we can find that again. It's in the graphic reports cross sections. That's called quick sections. So that should be the same as this. P, select. Yeah, see, it keeps creating over and over. Let's see, start 0, end at that. Let's go over 50 feet. Well, the section. All right, so now it's writing those. We put them up here. There's the first one. There's the second one. You can see where it hits that subgrade boundary as it goes along. Here, every 50 feet. Did it by chance? Let's see, did it make? Nope. All right, so that should be what it generates, but I wanted to be able to see that. Of course, you'd have to set up, all the colors and line styles and stuff to make that show up as a more intelligible report. But this right here, cross section, creates a section in one step called Quick SCT on the roads menu. Quick SCT. So that is supposed to be the same command. So command search. Quick SCT. Yeah, well, it's not doing it from this. Let's take it left to right. Design with subgrade and original ground every 50 feet. Here's my paper size. Include section rows per sheet. 11 by 17. 1 by 1 scale. Start at 0, go to 483. Say OK. So the file sctreport.pdf couldn't be opened because you don't have permission to view it. That's not correct. I do have permission to view it. But where did it put it? That's the thing. It should have put it in their file. I don't know. Are you seeing it on your end when you do that? Do you see, does it open up a PDF for you? The same thing. I don't see any quick section.pdf. Huh. Well, it would basically run something similar to that and generate cross sections for us. Let's take these and this out. Get our areas of interest showing on us there. Well, that could explain something. My file could be corrupt. All right, let's close this. Let's see what's going on here. File Explorer through Windows here instead of through Mac. Carlson projects, 3D machine control data sets. Getting started. Here's my cross-section files. So I made the cross sections. I don't see the PDF though. JPEG. Yeah, it didn't generate the PDF files like it should have. It did make the sections. Looks like I misspelled example there. All right, this gets ready. Let's load this back up. Turn the other back on. Yeah, it didn't save those areas of interest. Yeah, so I didn't save it with the areas of interest on after I did that. So it went back to the old version. Now, let's see if we can do the cross sections again separately now that we started over. Data source section files. Polyline. 50 feet. Plan view. Nope. And the file SCT report couldn't be opened because you don't have permission to view it. Not true. Well, you should not be getting that answer. So you got the profiles made and you can see them on the full plan set, but we don't normally make our own cross sections. Okay. It was just to be used as an analytical tool to see if it would help. So I would say you can ignore that part. Now, what would you normally see? We've done, our different materials. You saw the depth and you calculated, and you can view them. Let's make sure our view is still um, based on that definition. That looks good. We should also have, and we do, the curb depressions. We got the pavement, we've got the building, we've got the landscape area, and it's good for that. Now, at this point, I'm going to turn on design and turn on other. I'm going to go back to my settings, Carlson configure, take off SiteNet settings. I'm through using that for color assist. I'm going to turn that back off. Then I'll exit. And I'm going to set everything back to be color by layer. So I'm going to type CHPROP to change property. Select entities to change. I'll type all, hit enter one more time. I'm going to change C for color. And the new color is going to be BYLAYER. Hit enter to finish. And now we're back to those original colors in the file. And I'm going to freeze off these little skirts now. I'm going to just freeze that. I'll freeze our boundary. This was perimeter. Let's freeze that. I'm going to go up here and get my freeze by pick. I'll freeze that off. All right, so now I've got my basic, here's my face of curb, top of curb, back of curb. Here's my building. There's my building pad. There's that landscape area. You can see those little brake lines. Let's freeze them too, just for housekeeping's sake. And finally, I'm going to freeze these labels for the text. All right. So now we're back to like our original file was showing. I'll save that. And let's do some other analysis. We've got an existing ground, we've got a design ground, and from that, if we go and look at our display options, which is either take off, where do we have, or I'm sorry, not take off, but display options, or on the toolbar, you can choose that options, and we can see where we're right now looking at the drawing entities that made the existing surface, the design that made the existing surface, and the other. So we could, let's say, let's turn off our existing. And that is just like hitting the button up here. It will go away once we say okay. We'll keep our drawing entities open, but let's turn on our contours for our design. So there now is the contours that we set that were created. And if we wanted to create those, I'm going to go back and freeze. Some of these things again. We've got now the contours are shown, and the contours are on. There's a layer here called contour index, D for design, contour D, that's my design. contours. So I could set these layers. I've got design existing. So here's my design. Let's, instead of making those red, we'll make them, this sort of darkish color, and we'll make it, we'll give it a line weight, let's say 30 millimeters. And then our regular contours will make it a little bit darker, 252, and we'll give those 18 weight. Need to make this 253. And let's see what that makes it look like. Display. The MSoft scale is on. Let's set our contours up a little heavier so we can see them. Contour D. Let's make it 30. And contour index D will make 50. And let's make those, instead of those colors, these are the regular contours. We'll make them yellow. And the index will make red. So there now is our grading plan that shows our contours for that design surface that we built. And you see there's a contour runs down through our parking lot here. And you can see, because you see how it comes across here, goes across the back of the curb, and then it walks down the face of the curb all the way up to here to where it hits the face, comes back around, gets close, doesn't quite get there, and then it gets over here and then climbs back up the face of the curb, keeps walking around the face of the curb till it gets over here and it runs off the surface. There's some other areas. These contours are outside, but you can see how this contour hits the face, walks up around it, and then comes back out. Let's see, here's one. Hits the face, walks all the way around it till it climbs back up and then goes back out. I want to see one where it comes up and crosses. Here it is. Hits the face, climbs up the face to the top of the curb. So there you can see the face is at 1780, and then 1806 at the top. This contour line is 818. So that's already, it's a little bit shy. This guy is at 817.8. This guy is at 818.3. So it's right in between. That's along the face of that curb. In fact, it comes right over here, comes across the top and starts walking down the face of the contour. It goes all the way over to here. And at this point, it's headed back up and then crosses, comes across. A little discontinuity in there. It jumps across because that's the same elevation across there. That's just a little glitch. Then it comes out across and comes back off the curb, across the pavement, hits the edge, and walks around. So there's our design contours. If we needed to create those, we have them. We go back to our design options, and now we have, see, here's our contours, and you can set up all of the different, layer names and contour intervals, that sort of stuff, where you can set these up. Now, we have also cut and fill labels, colors, and a map for those, but we've also got cut and fill contours that we can generate. And we again say the same thing. So you're going to get layer names called TK for takeoff, then cut fill contour. So that would generate those. All right. And the cut and fill, I want to, let me see if I can establish this. If I go to if I make a target, I'm going to call this freeze. And I'm going to go to other, and let's save, exit. This is on a layer called PR-ELIV. All right, so back to my definition. If I go to other and find PR-ELIV, and if I move that to freeze, save, exit, and now if I freeze this, I should be able to turn on my design, turn it off, turn on and off my design. The first was, and then other and other. Okay, good. They'll stay frozen because I put them on that other target. Now, let's do, ah, there we go. I've got perimeter. I want to move that to freeze. And surface boundary. Now if I freeze those, there we go. All right, so to analyze our cut and fill, we're going to, we can choose either to draw the cut and fill contours, get the labels, or a color map from our toolbar over there or from our takeoff menu. We can choose well, display cut and fill. It should be in our calculate as well, but oh, also, if you remember when we did our definitions and we said things like this, and we could hit this set button and we could find all the ones. Well, it looks like it got rid of the ones we did before because I didn't save it apparently. All right, so anyway, to get that back, as you create those new ones, it starts to accumulate those, but you can go to your takeoff uh, menu, and then you can do the, you can edit that library independent of that process. Under material quantities over, it's a pull right where you can define the materials library. And that's where, here's where we added those things from, we could say We can give it a different category name. Right now it's just by takeoff. Let's see if we find, yes, I'm gonna find anything there because it's no longer there. But that's where you could put in things like concrete costs $25 per cubic yard, set your shrink and swell and your densities and all that kind of stuff. So that lets you build that independently of that other. If I hadn't had that little glitch in here and if we still had that set button, it was bringing those up. If I go into that command from there, at that point, then it would have saved that as a library. Okay. In fact, I wonder if I remake design, and re-report, there's all that materials. And now, if I do my materials, define my library, now it still didn't. I look for concrete. Yeah, it's not finding it. So if I had done that without having the error, you would have seen that come up. Define. Material entities. Yeah, so that would have been building materials. We select it from our pad, building pad, except it was just plain pad. Yeah, I'm sorry, no, because I had that issue on the file. I'm not getting my list of those libraries, but anyway, you can, as you work with the software on different files, as you identify those materials, make sure you go back to that materials and do that materials library so that you can capture those and they stay in a library. And then you can run those with other files at a later stage. Okay. So let's see, what else do we want to take a look at here, and then we'll break for lunch. We'll come back after lunch and look at our cuts and fills. And here's a couple of other things under our surface tools that you've got. You've got these surface managers, which let you load up the surfaces and do those edits like adding break lines, removing points, and all those, just like we did in the viewer. But you can save the current to the list. Yeah, I'm not sure that it gives us a way to manage those. But under our surface tools, see if we set the active surface existing in design. That's good. Surface inspector. Now, as you're looking around, here's under existing, that reads the elevation, the unadjusted, and then the design depth and how much fill is in that area. And I'm just hovering the mouse. Now I'm here in the building and I see within the building footprint, I see an existing elevation, an unadjusted design elevation, and then I've got a design elevation of H1703, which indicates a depth of 1.67 feet, which is that 20 inches for that subgrade depth. And at that point, there's a cut from the existing down to that depth of 0.193. Okay. So that's a nice little way also to sort of, visually scan through and check what your, um, what the comparisons are going to do. And just right click. I think, yeah, if you click a spot in the drawing, it will actually drop a label down there for you. So I'm going to get rid of those. As well. So, you could do that and say if you wanted to put spot elevations on this thing after you finish your design, you could do that. Just click that spot. But under the surface tools or the takeoff under surface tools, down here's where I wanted to get to. We've already looked at some of these reports and such, and there's a cut and fill business. But this import and export business is where you can export those to these other formats. So if you export, these different, here's our export to triangulation surface, the design with the subgrade topsoil replacement or just the subgrade removals. If I export that and we'll give it a name, that's going to actually write out that demo1-fn.tin file to that different named file. And then we could use that to put on a dozer to do our work. But there's also I wanted to export that into a different format. I think that's going to come from our surface menu, import, export. And here's where we can export to these Trimble and TopCon machine specific files that we can do. You can also import those if you've got them from different developers, maybe have given you that as well. So you can import those and export those. Now you can also, sometimes you'll get from a designer, from the engineers, you'll get what's called a land XML file that includes that final grade, for instance. So if they've managed to give you that, instead of taking it from here, where you can import, well, there's a Google, TopCon, and Trimble, but you can also, just on the file menu, under import, right in here's your land XML file. So you could bring that in as your finished design surface, just like I did with that one that I made separately, that file that I called demo one with specific design, whatever I called it. And then you could go into your definitions under design, change this to file, select that file, and then use this to start pulling in your subgrades. Now, do you all do you get involved with these surfaces that go on the dozers and such for machine control? Do you know what I mean if I say doing a dial down? Okay. Okay, good. So what a dial down is is, let's say you're out there grading a building pad or you're grading a parking lot or whatever. If all you have is the top surface, you haven't created these subgrade areas to where you actually get to the bottom of the subgrade, you can go to your dozer or to that file that you're going to put in your dozer. And then once you're out there working on the ground, you can dial down on the controls of the dozer a certain depth so that you're saying, okay, I'm reading the top, but I'm going to set my blade to dial down to like that 1.67 inches or whatever it happens to be. So it reads the top and it constantly subtracts that amount from it. So it's preparing the subgrade. So when you put the subgrade materials back in, then you ultimately wind up at the top of the surface again. That's what is called a dial down. And a lot of companies, a lot of contractors will actually do that as an option. They won't go through the effort of creating these subgrades, but if you have that information, it's a real nice way to get there directly. But let's say you haven't done that and all you've got is the top of the design, then under your surface, or under takeoff rather, under surface tools, you see you've got here a, somewhere I saw it here a minute ago. Let's see. Oh, design surface vertical offset, same as existing. You can do that right there. And that will take that vertical offset. It takes that design surface and puts in that dial down for it. But now it does it for the entire surface. So uh, if you were to do that, let's see what it gives me. Adjust the entire site, or within a perimeter polyline. So if you set a perimeter polyline, for instance, the offset amount, let's say, was 12 inches. Let's just say a foot. So 1 foot. Now select the closed polyline. Well, this might, and it, again, has to be closed. So this is um, the pavement, right? And it didn't have any cut and fill labels. Now it's done. So let's repeat that. Let's see if we can do that one more time within a perimeter. Let's make it 5 feet just so we can see it. All right. And we'll come down here and grab our perimeter. All right. So now we've adjusted that to be 5 feet deep instead of reading that subgrade information. Let me take a look at our surface now. I've got this adjustment with subgrade. I don't know that this is going to, no, that's not 5 feet. Well, I don't know, it might be because that's 20 inches. Let's look at our surface inspector a minute. Adjusted 812, that's existing. Unadjusted designs 821. Design with depth of, no, see that didn't do that with that one. But let's see. Let's see if we picked it up. Yeah, we did, but it's 5 feet up in the air. Let's do it, adjust final. And do by perimeter, uh, perimeter, -5, let's say. All right, now we'll take the inside that it's now done that. And if we look at a quick profile this time, it still didn't. It still didn't. Just final by perimeter. Offset amount. Let's go -10. And this time, instead of getting that one, let's just do the building. There we go. So see within the building, you can see where it dropped it that additional amount. So now we've defined the subgrades. So if you don't define the subgrades, but you do want to have the surface lowered or raised within a particular closed polyline, you can do that. And that effectively creates that dial down for you. And that means it doesn't dial down the whole surface. It only dials down within that boundary. Okay, so now you can see within the building, it went extra 10 feet. That's another way of building basements, for instance, inside buildings. But it's usually done for doing road beds or parking lot subgrades, that sort of thing. Okay, so if we look at that, let's see if it picked that up. See, it's still, yeah, there it is. It picked that up 10 feet deep. So let's do that surface tools vertical offset for design. And let's say an entire site, an offset amount, let's set back to 0. So there's nothing done. We'll do another quick profile. Now we should get everything. No, still didn't erase it. I need to just remake my design. Now let's take a look at that quick profile. There we go. We're back to where we were. Okay, and verified that by our views as well. 20 inches for the building. I forgot what we said for the pavement. Make sure I've got that right. Base of curb. Yeah, that's 23. And so it's deeper than the building itself. There we go. That makes sense. Okay. So that'll be a good spot. We can break for lunch. Save our drawing. I'm still, yeah, boy, that's a shame. Sorry that when you do that and you don't have that glitch and you save that as a material library, then you can use that library in other projects as well. So you don't have to keep entering in all that cost information. But anyway, sorry, we lost it. All right, so when we come back up to lunch, we'll take a look at the cut and fill tools and then be thinking about other things that like maybe have occurred to you. How would you do a particular approach? How would you look at something? If you do road design, for instance, maybe that's a different approach. You want to look at some of these road tools as opposed to this takeoff type of thing. And takeoff, again, is what the name says. It's where you take off your quantities. It's how you generate your estimates and how you do that. But along the way, because it's so accurately doing the calculations, you can take those computed surfaces and actually put them on dozers and such and go out there and actually design down to the subgrade and get the whole site ready to be backfilled and then created up to the top. Okay. So let's come back at 1:30. Um, but like I said, be thinking of a couple of things. If you got any specific questions or anything in particular that you'd like to look at, we will look at the cut and fills when we come back. Because sometimes that's something that people want to see. And that should wrap us up, get us ready for the rest of the day, and that should wrap everything up for us. All right. Questions to this point, though, before we go? Everything good? Oh, good. Okie doke. I'll see you at 1:30. And let's pick up where we left off. So we were going to look at the cut and fills next. And also you were going to think about anything else you'd like to take a look at for later on. But anyway, just to display our cuts and fills, if we look at our cut and fill contours, for instance, let's see, let's go to our display settings and let's do our cut and fill contours and let's make them every 1 foot. That should be good. I won't do any smoothing. We'll go ahead and label them. And it should be all right. Say label. Um, 2D hide underneath. All right, let's see what that gives us. And now we'll turn on to see what the display cut and fill contours. And there they are. Looks like they are red and green. Let's change them to be let's make cuts red and all right, I guess they're all red. TK red. So there's our cut and fill contours. And so there's -2. Let's set our style for standard here. And save the drawing. All right, so there's 2 feet of cut within there. Let's see within that. And here is our 0 line. Let's go ahead and give that a little weight so you can see it. So there's the 0 line. So everything down here is in fill. So there's 3, 2, 1. That's the amount of fill. The red ones up here are in cut. And you can take a peek at that in 3 dimensions just for some context and verification. Oh, they draw them down at 0 elevation. How interesting. All right. Well, no, I guess they're not at 0 elevations. They are at that elevation at 0, -1, -2. So that part's all right. All right. So here's there's basically a foot of cut for that pad because we dropped it down for that material. Um, here's our within the building footprint contour as it comes across and climbs down the face of that subgrade and then climbs back up and out and comes around. So that's our cut and fill. And if I turn those back off, now we've also got this, we can do labels. And as we do those, it's going to set up the elevations of the white labels are on there. Cut fill text here, like they're up. But it's the, let's go to our surface inspector. And as we hover around here, you see the existing ground is 817.33. The amount of cut is 0.29. See there, so that's at negative 29 in there. The unadjusted design is 818.7, but the adjusted design at a depth of 1667 is 817.03. So the adjusted design is on the top, the existing is on the next row down, and then the amount of cut or fill is indicated with our little chart. So you can see how quickly we've done that. Now, a lot of contractors like to see these so they can go out there and verify, that they're getting their excavations done correctly. All right, so we'll turn those back off and let's do a cut and fill heat map. Now, what that is basically red through white through blue, blue being fill, red being cut, white being neutral, where there's relatively little. And it's the intensity of the color that indicates relative depth. So there's a lot of cut up in here where it's really dark red, and but little cut down in here where it's sort of pinkish looking. Same thing with dark blue and light blue and then white. Okay. And you can control all of those. If I go back to my display settings, look at my color map, I can automatically set the range, or you can set it if you want. You see those little number of subdivision rows, it says 100. That's these little rectangles. That's how many little squares. So it puts down these little squares and colors them in based on the amount of cut and fill within that particular area. So you can make that, if you up that number, let's say to 200, you see how they come back and now they're smaller because it puts 200 of them across instead of 100. So it gives you a little finer gradation. It's sort of like increasing the resolution of your monitor. But if you get them too large on a large enough site, they're going to be, take you forever to draw them. So you can put them back to here. If you uncheck this auto set range, you can set your range up and you can here use your coloring red, white, and blue, red, yellow, blue, etc., etc. All right, so let's turn our map back off. Now you've also got, along with that, on the takeoff menu, it's not on the toolbar, I don't think. Let me see if I got a cut and fill labels. Label existing surface, label design surface, hide under the labels, label colors, color by depth, color map. So there's nothing here that I was looking for, but you can draw under the takeoff menu, under your cut and fill. Maybe it's under display rather. Cut and fill. I want to draw the legend. It's not. Actually under display either. Let's see if we put it, should then be here under takeoff. cut and fill centroids, the cut and fill map legend. So it's under surface tools to the right, cut and fill map legend. So if we pick a point over here, it's basically saying, okay, so from the darkest reds, that's 6 feet of cut up to 6 feet of fill with the darker blues, and around 0 is where it's in the mid range. Okay, so, and again, what it creates, if you look at that, you see it's made a block of all of those grids. Same thing with that. If I select that, you see it's just a solid. It's a CAD entity known as a solid, and it just plops them in there. It makes this block out of all these solids, all edge to edge, and then just gathers them up and creates a block out of it. All right, so again, it's sort of an indicator of how much you're going to be working on. So you could then turn off the heat map and just simply erase the legend if you'd like. And that's really about all there is to cut and fill. You get the reports, you can get those little maps. Okay. Let's see here, tunnel volumes inside a perimeter. So if I look at everything within the back of that curb, no exclusions. Again, that works just like the area of interest did, but I just can pick one that's already drawn and limit the report to what's within that particular area. Anything else much to do here? I think that should do us on the cut and fill bit. So, um, so what else do we have here on our set of menus we haven't really talked about? We've used a couple of things as we've gone along, and you've got the workflow down now, I think. You've got this. So, and again, I like to use these toolbars because they sort of work left to right in the order that you would typically do certain things in. And that's basically taking the commands that are most used and putting them out here for your easy access. Um, but if you look at file, edit, view, draw, inquiry, settings, and points, those are your standard menus, and they all have the same commands, and just like they do in civil and survey and everything else. Elevate has a lot of the same commands that the civil 3D data menu has in it. Okay. And this is where you can set elevations. You can change elevations. And we've done that a couple of times. You can either be a differential, so you can raise something up or lower it down, or you can do it by absolute, or you can do it by a percentage. You do it as a scale amount. And as you change those, you can even change the layer, put them on a different layer if you'd like. So nice handy little tool. But you can also, particularly if you're doing an absolute elevation change, it's simple enough just to simply select the polyline. If it's a 2D polyline, meaning it's planar, not meaning that it's 0 elevation. But if it's a 2D elevation, then you can select it and just type the elevation in the elevation field in the properties. If it's a 3D polyline like this parking lot, face of curb, you can see up here at the top at this pull down, it's a 3D polyline. Well, there is no elevation field. There's a vertex Z, and that's for each of the points along the line. You see the little red marker on the screen as it's stepping through each of those points. Those are the elevations of that particular point. And so you can specifically change one of them there if you know what that elevation is supposed to be or what you'd like it to be. But you can use that change elevation on that 3D polyline instead of, well, you could set it to an absolute, and so that flattens it to that absolute number. Or if you say differential, it keeps everything relative to each other. So as it goes up and down, it will keep that same up and down, that it just takes the whole thing and picks it up or lowers it down. That's our differential. A couple of other tools that we used were when we set the curb faces from those labels with the leaders that set their elevations. We also then set this line, we did before we elevated it, we just did a 2D offset and set that back just 0.05 to be the top of the curb. So if we're looking at that, it looks like this. So we did the green line down, what is it, 0, and we just offset this other one just to the away side from the base. And then we elevated it with those other text and leaders, the ones that said, the top. And then, and you can see here's a place where there's an example of that depressed curb, because the top elevation of this white line was not consistently half a foot above the bottom. Okay, so that's how that changed. And then once we established that elevation of this top line right here, we did a 3D offset by interval, and we went back 0.45 to make for a total of 0.5 from the front. So we went back to that back line as a horizontal offset amount and a 0 amount vertically. So if we didn't have these differentials like these depressed curbs, we could have simply set the front and then done a 3D offset, set the face or set the top and set the back if it's consistently 6 inches above it all the way around the building. But because it wasn't, because of those depressed curbs like you see here, we had to do one with one set of labels, another with another set of labels, and then we took that line because the back of the curb we assume is going to be just the same elevation as the top of the curb, just 6 inches behind it. And we use that to set those elevations. So those are some of those commands that we were using. So some of the others on elevate is you can set a polyline to an elevation. Now that could be, and that actually runs a command that changes, it converts a 3D polyline into a 2D polyline by putting it at a specific elevation. If you do change elevations, absolute, and you pick a 3D polyline and you flatten it to that number, that still leaves it being a 3D polyline. But if you choose set polyline to elevation, that actually changes. If you look down here on the status bar, you'll see what it's telling you. It changes a 3D arc line or polyline to a 2D line or polyline. So it actually converts the entity type into a 2D polyline, right? Then this next command, this polyline elevation editor, that's one where we could, let's say if we noticed a spike in our particular, what is that, PR gutter? I really need that one. But if we had a spike in a particular line, like there's that line just joined around that back edge. So if we use that, we could do this and step through all of these vertices and change their elevations. But this editor gives us a number of other tools. We've got specific ones that show up as red. Those are held as control points. If you uncheck them as control points, then what it has the effect of doing is changing, or it frees up the elevations of the ones you uncheck or leave, and it holds the 1 point elevation, the one that's the previous one checked. Like in this case, this number 4 is checked. The next one that's checked is number 8 up here. So that means 5, 6, and 7 float, and they just interpolate between the control points. So if you got a spike or something in it, like you see our little picture here, I'm here, and then as I go down, as I step through the vertices, you see it climbs down, 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 down. I get to the bottom, and now it's going to come back up, you see. So if I didn't want that to go down and do that, if I just wanted it to go from here, say, a little more smoothly up to there, I could come back here, sit on this one, right? Well, let's sit on the one that starts right there. That one is locked. These others are all locked, but I could go to this other one. So that's number 8. And if I want to go all the way up here to number 23, that's locked. So I can select number 9 and come down here to number 22. I'm going to shift click so I get them all. I'm going to uncheck them and watch the profile. You see how it changed that dip and climb? So they now climb up from here all the way up to here at a consistent rate of climb. And that rate of climb is this little 3.588%. Now you can control that. You can type those numbers down here. You can type specific elevations. Okay, so it's a really powerful little editor once you're comfortable using it. You can, let's say you've got these slope in, slope out, but let's say if you need to go, instead of going from here around to here, let's say the numbering is different. Maybe the order of the polyline goes around this way and comes all the way back around. So you need to change the direction because it's always moving forward. So you've got a tool up here, right here, that just reverses, excuse me, reverses the direction. So then the numbers all will shift and they'll change and you'll be able to do those around. You've also got some other tools. You can offset, you can pick an elevation from a surface to set the elevation of a point. You can add a vertex where something crosses something. You can create a new vertex along the line. Now, what it doesn't do, if I create a new vertex, it keeps the alignment. Like if I pick over here, it's going to make a point right here. So it stays on that alignment, and then I have to tell it the elevation. So a lot of different tools, a lot of different things. You've got settings that you can look at. You've got a report that you can, it's just, you get a report of anything that you want to look at in terms of that polyline. Here's our settings where you can set to label the control points. You can label non-control points. In that case, they're going to show up as blue, but with labels. I generally don't label them, and you could even hide them so that the only ones you see are the control points. So just whatever makes it more convenient for you. Let's see, press escape to cancel. Base elevation, slope mode. You can set to percent or ratio or degree. You know, just a tremendous amount of control that you can use to do that with. You've got undo and redo in right in here within the editor. If you choose this icon, you can go ahead and pick a different polyline to do the editing. And if you do that, it saves the changes you've made to the one you've been on. Otherwise, you can stay here and just apply and close. Now, I will give you a little bit of warning that when you use that command, occasionally, if you click outside of it and you're trying to work around over here as you're working with the editor, sometimes that'll get a little bit out of, not out of synchronization, but it'll sometimes, at least in the older versions, I haven't had it happen for several years now, but it would sometimes hang, at which point you could still do commands in here, but the thing wouldn't go away. So you just have to save the file, get out of it, and come back in. But you've probably experienced that with other commands as well. Okay. So some different things there. You've got a wall polyline editor, which is really nothing more than this same type of editor, but it sort of, if I have a, let me see if it's illustrated. Would be, we've also got it here in the 3D data wall polyline editor. That creates a retaining wall object using a polyline that defines the alignment and attaches a top and bottom profile to it. Okay, it's recognized by surface modeling commands. Top and bottom get built into the model. The wall polyline is also used in SiteNet and Takeoff for building the design surface, including subgrade surface for the base of the wall. Okay. So what you would do is you would draw the polyline so that the left side is the low side and the right side is the high side. So basically the base of the wall, and then on the right-hand side of it, you're going to make the top of the wall. You can reverse those if you need to change that to where you get one is left and right. So you always want to go with the direction of the polyline, and then what's left of it is the base, what's right of it is the top. Okay. And so it will ask you to select them, etc., and then you would create those individual elevations, and you'd basically type in these elevations for all the little breakpoints along. That's the foot of the wall here. This up here is the top of the wall. So it creates that. Now, I don't ever use that command. And the reason being is that when I go to build a wall, I'll actually draw that stuff in and I'll work on those things independently. So if I did that, for instance, I would do something like this. I'm just going to draw something like that as a draw polyline. So if that was my wall, or let me, instead of doing it as a square, let me just do it like this. I'll draw a 2D polyline, say like this to this, okay? And if I know that that wall is, you know, if it has a batter, if I've got a thing, I'm going to offset. Now, again, these are just 2D polylines at this stage. So I'm going to offset that. This is going to be the top of the wall. I'm going to, or maybe let's call it the base of the wall. And if I offset that, I would pick, let's say I'm going to say 0.1 as my amount to offset. I'm going to go over here. Now I've got these two lines. One's going to be down on the ground. This is going to be up on the top. Now let's say that wall is a foot wide. So I'm going to offset that one again, 1 foot. So I'm going to go here to here. And then to resolve this one, I'm going to go down another, that 0.1. So I'm going to offset again to 0.1. I'll go here to here. All right, so now I've got the tops, and I'm going to go ahead just to help us keep track of them visually. I'll make the top this blue. I'll make the bottom yellow. And I would, now, sometimes when you've got this top up here, like this bottom it's not just a freestanding wall out on a flat plane. Down here's the bottom, and then up here's the top of the ground, which is at a different elevation than this down here. That's the way walls are typically done. So what we would do at this point is we need to put these lines here on a surface. In other words, the ground. In this case, it would be, the paving surface, which is that design surface, or it could be the existing ground. Let's just put them on the existing ground for now and see. So I would do that with my elevate commands. And then I would say 2D to 3D, and I would choose that because I've drawn 2D polylines. I want to now make them into 3D polylines. And so I would choose that by surface model. And if I do that now, I'm going to pick the surface that I want to drape that on. So I'm going to put it on Demo 1 OG. That's my original ground. I'll say open. It says select the polylines. I'll do this one and this one. And again, there would be at different elevations and normally considerably different. All right, then you can add vertices at grade breaks. What that means is if the ground goes up and down and whatever along this length, every time it changes direction and goes up to a high spot or down to a low spot, I want to add a vertex into this line. If I don't have this on, the only points it puts on the ground are the vertices that are in this original line. Let me zoom out so I can point to them. So if I don't do that, if I do that same command, choose that OG, and if I choose that one that's on the ground, and if I don't say add vertices at grade break, then the only points it puts on the ground are the end point here and this bend, and the other end point. Now, that's very common that we do, for instance, if we're drawing in something like a water line or a sewer pipe or something like that, that we know it's going to be, let's say in case of a water line, is we're going to put it on the surface and then we're going to drop it 4 feet. So we would not do this. We would uncheck it. We would only put the ends on the ground. So that's going to set its general slope. And then we would give this vertical offset of, let's say, -4 feet. Okay. Get the idea of what we're doing? But I'm going to add vertices at grade breaks. I'm not going to apply a vertical offset. And I won't keep the existing. I'll just create that. So I'm going to say, okay. So now it's elevated to 1. I'll repeat the same command. And let's get this guy. Same option. So that now sits on the ground. And this elevation is, what is it, 813.3. And out there's the grade breaks. And out here it's 815. So let's make the top of this wall, say, 820. So I would take these and make them 820. So I'll just change their elevation right here to 820. Now they're staying as 2D polylines, which is fine. But now tops of walls are rarely level. So they usually go, here and they run along a certain distance to a different elevation. Then maybe there's a step up. Maybe there's a line of bricks or something that makes it step up to a particular level. So I would do that same thing, but make it into a 3D polyline and, set all the top wall elevations as I go along. And then maybe I'll do a 3D offset to get the other side of the wall over here. That was a foot tall. So right now we'll just keep it level. And now I'm going to come in here and draw a 3D polyline to connect the base points here. So the first thing I'm going to do, though, is I'm going to draw a 2D polyline. from here to here. And I'm doing it as 2D because I want to offset this same distance, 0.1, from here to here. Now I'm going to take this 2D polyline and just throw it away, and I'm just going to use this to trim the tops. All right, and I'm going to do that same thing over on this end. I'll draw the 2D, go from end to end, offset that same distance, cut it back, get rid of this, use this to trim these. You'll see why here in just a minute. Now I'll just take this and throw it away. Now, I've got things at some elevation. You can see when I look at them, let's go ahead and look at them in context here. Right now, so that yellow sets of lines are down on the existing ground. You can see they're down below the parking level. See right in here how that one drops down. So that sits on the existing ground. This is the top. Now, it doesn't look very much like a wall at that point. So what I do is this. Once I've established the bottom elevation and the top elevation, I'm going to draw a 3D polyline. And I'm going to make sure I do not have checked to prompt for the elevation because I want it to read the elevation and just go ahead and use it. And I'm going to, down here, if this says use the current drawing properties, I'm going to uncheck it, and I'm going to pick, and I'm going to pick this layer here. So I'm on that same layer. Now I'll say, okay, and I'm just going to grab the endpoint and grab the endpoint. I'm going to do the same thing over here. So I'll repeat the command. I've already got my layer set, so I'll go from here to here. Okay. I'll repeat the command again. And I guess these are all on the same layer, so that part doesn't matter. Let's just set well, we'll leave the color alone. All right. So now I'm going to do from here to here. Now that's going to be all at that 820. And over here is going to be 820 to 820. Now here's the cool part about how we can make this look like a wall. Let's change, I'm going to match the colors so you can keep track of where we are. So I'm going to go up to my little icon right here, that little paintbrush match properties. And I'm going to choose the blue line there and choose that line as my target and choose this line as the target there as well. I'll repeat the command, choose the yellow one. So all I'm really doing is changing the color of those so that they match. They're all on the same layer, but now they are there. And you could turn those into connected, closed polylines if you wish. There's no real need necessarily to do it, but here's where we can do this. All right, I'm going to make my object layer current. I'll make that my current layer. I'm going to now draw 3D polyline again. And I'm going to put some visual aids. And this is going to work. I'm going to set the color to be this cyan color. This is going to have the same effect that we did before. I'll do it again. Go from here to here. So this is going to have the same effect as all of these little sidelines down here being drawn to sort of give us a visual context of what's going on. So I've now drawn them here. I'll now repeat that command, and I'm going to draw them from here to here, and I'll just go right straight across the top here and here. Do the same thing here. Repeat the command. Snap, 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 snap. And then finally at the end, here to here, and then here to here. Okay. So now when I look at this in my 3D viewer, you're going to see that it looks actually a lot more like a wall. So there it is. So that's generally the way I do it. And sometimes if you have long ones, you can put intermediate ones, like go to the midpoints or go to the near points. But as you can see, that actually has, you see how the base is following the ground, but the top is at that constant elevation that we set. And if we had, like, it went to a point and jumped up and came across and jumped up and came across, we could put those jump points in as long as we remember to lean them back just a little bit so we don't have any vertical edges. And then I would simply allow that data, those drawn lines that we made, I would let that become a surface or go into being part of my surface. So this other one under Elevate, this wall polyline profile editor, whereas it does sort of the same thing, except it only does it with two lines. So I would have a line like this, and then I would need to have another line next to it to be the top. Let's see, let's repeat the offset. Let's make it a foot just to get a difference. So we'll make this one yellow, this one cyan. So what happens when we flag it as a wall polyline, it sets the one on the left as the base, and the one on the right is the top. Okay. So instead of like what I did is I actually built the darn thing and used exact measurements. I've got a foot across widthwise and I've leaned it back just that inch. So here now I've got this one. And the difference is if this is a wall polyline editor, it says pick the retaining wall polyline. Here it is. The surface that it's going to go on, there's that OG. Okay. And so now here's how this part works. And you can, this is sort of reminiscent of the 3D viewer, but I've got two different, so which profile am I editing? First the bottom, then the top. So if I do the bottom first, it's reading that surface and it's reading these different points along it as it goes along the surface. Like there's one that I might even want to take that one out. I'll just select that and remove it. So as I zoom in here, so that's going along the ground. Now, if I want to do the top, that's this white one that I would say, let's make that also 820. So I'm going to take all of these. I'm going to remove. That's at the end now. So here, I'm going to set the elevation of 820. Here, I'll set the elevation of 820. Okay. So that would be the bottom. That would be the top. I would say, you can create the solid or you just say, okay, well, let's go ahead and create the solid and let's call it wall solid. Then we're going to okay. And you got these other buttons, match the start, match the end, etc. Say, okay, so now I've got these drawn. Again, let's look at them so you don't see it, right? Because right now it is still a 2D polyline. This is still a 2D polyline. What would I do to put that in there to see it? Now, I don't have to do anything because I've created that wall polyline. So it knows it's a wall polyline. So if I pick that, you see it retains that information and I can see it here. That would be how it creates itself. But it doesn't actually draw it out here in my drawing. But when I go to make a surface out of this data, it will take that, it will read it and make the wall for me and create it as part of the wall. Okay. But it doesn't do any um well, I guess you can make some steps and stuff in it. And you can also here I've got a top width of 1 foot, a bottom width of 1 foot. So it really should be, something like 1.2 feet at the bottom. But even if you made it like 5 feet at the bottom, you see how it creates that. Oh, if we just make it one, and then you can set a very depth of, let's call it 1.5 feet. All right, so there's a few more little controls. Face the layback slope. Vertical, you can't really, it shouldn't really be that. It should be a particular layout. You'd have to calculate either the percentage or the degree. Surface view, color texture, edit mode free. Okay, so as you do that and create those polylines now, so there's the beginning, there's the end, look at the bottom, there's the beginning, but it has intermediate points in between it because it draped on the surface. Um, so then we go to build the surface because we've flagged it as a 1 foot wide wall with something on the ground, something on the top. It's going to um, create that. It's going to basically elevate these two things, just like I did here, but it does it all in memory, uses it to build the surface, and then goes away. Now, when it does that, it builds this as part of the surface, and it would be actually, we could give it, um, the depth of the foundation and all that kind of stuff. So it would take care of all of that excavation for us as we go along. So depending on which one is your preference. Again, my preference is to actually see the darn thing out here, make sure it's correct. Otherwise, you can use that wall editor and it does really the exact same thing. Okay, other than you're not having to create the geometry yourself. Okay. So, and then, um, so I guess let me see if there's a question about the freeboard here. So if you got a particular freeboard, let's give it a foot of freeboard. And it doesn't show any of that. Yeah. Yeah. So it doesn't show the freeboard part, but the bottom base is over here. And then the surface comes into the back side of it here um, from the top. So this is a retaining wall. It would be open here on this side, but then there's dirt stuff behind it on this side. So that's why I generally like to do it instead of with this editor. And again, it's your preference, but I like to do it like this because I can actually build it. And then I would actually have this back line, instead of being down here basically level with this line, it would be up to whatever the incoming slope would be. I would drape this on that part of the ground, just basically just below the top of the wall. So I would maybe make that look like this. Let's call it, let's give it a foot of freeboard. So I would go to, let's set my polyline to elevation of 819. Let's call it 819.5. We'll just give it 6 inches and we'll set that. Okay, now, because we've changed that, this line no longer meets that line. So I would need to look at this. I'm going to just zoom it up here. You see how that didn't change? So I'm going to grab those and snap those up like that. And I would do the same thing over here. I would grab these vertices and snap them up accordingly. Now, when we look at that in our 3D viewer, I can still see the effects, and I would have other, oops, sorry, I've got a couple of others I need to fix. I need to fix this one to go from wherever it is there to there. Make sure that works. Sometimes in 3D world it doesn't, so I'll take that to there. Now, let's go back to it and look at it in context in our 3D, and now you can see I still missed. Oh, I guess I didn't capture it. There we go. So now as I look at that, I can see that it goes from here. It's got a nice tall front face on it, but then the ground slopes up here and the ground comes down here. It's going to hit it right below the top of the wall all along this edge. And it's not always necessarily just 6 inches below. Sometimes it's, specific locations. Sometimes you've actually got part of the surface made back here so you can drape that on the surface. You can drape this on the surface and then just create the line work as you need as you're going along as doing those edits. Okay. So that's my preference. I like to do it so I can see it. I'm really comfortable working in 3D. So, you know, and all it takes is a little bit of practice. But that's, how I would need to visualize this. So I go from the front face down here on the ground. It's going to go all the way up to the back part here to catch it. So that would basically be all of the break lines that I need to then create that as part of those surfaces. Okay. Let's see if we can add these in. They're on cross section, I think is everything. Let's see, they're all on cross sections. So if we go to our list, go to existing, let's go to other, choose cross section. Let's move those to existing. And now for existing, now I don't have them drawn as closed polylines, so I'm not going to give any depth or material information. But now if I save that, I'm just going to display my existing. There they are. Turn them off. Let's see. I'm going to make my existing. Okay. And I've got a couple of crossings in here where, yeah, see, I'm crossing that, crossing those contour lines. Let's see if let me break that out. So I'm going to break from there to there. and do the same thing here. All right, there we go. So I'll now make existing, and you notice it lit up that wall because that it recognized it as a retaining wall. So now if we view that surface, let's view the original ground. You're going to see those, and you got some unfortunate triangulation in here. We didn't have some other brake line controls that was down there where I just killed those. And what you call it, where I broke those contours. So it's going from the contour jumping up to the top. So, I would normally have, I wouldn't have my existing ground, this low back here. And you can see how it's come up here and created it. But it also, I would need to fix that. But you get the idea how it's bringing that into that little bit of business back here. It read this, now it went from the existing, and because that was a wall polyline, it treated that as the top, 1 foot away. There's my base. It's draped on the ground. So is the base over here. But you see over here where I've got this, I get a little bit more finesse on some of that. I'm not sure that there's any particular advantage one over the other. If I change that freeboard, let's give that a freeboard. Let's change the top. Let's make it 825. 823.5. And let's give it freeboard of 1 1/4 feet. All right, we'll say okay. Let's do one more time. Let's create the solid. Say okay. I'll show what we'll do with that solid here in just a minute. Now we make the existing again with ignoring these contours here for the moment. And now go back to view that original ground surface. You see, I built my freeboard in as that little 6-inch drop because I created the line, and they've built their freeboard based on the mathematical number that I typed in, that 1.25 feet. Plus theirs has a height here, and it goes to a lower height down here. And you see how these things are sloping all up. Which again, you would control those with brake lines if it doesn't do this. Sometimes our wall does this and it's got to slope down to it. But again, I generally create the geometry myself and add to it. Now, if I add, I'm going to go to my model tab, and I'm going to load a model right here. And no, it's a 3DX. I've got a solid. It was an MDL solid. If I draw, let's see here, draw. Yeah, create solid. Makes a solid model for the wall, MDL. All right. What do I do with that? An MDL model. I can't view it. Can't insert it, I don't think. No. You do a quick check. MDL model file, or let's see, MDL solid model file. Model definition language files are text-based files to define the structure of 3D models. Okay, that's great. SolidWorks, MDL materials. Save view solid. '3D viewer. Okay. Let's see if it's here. View 3D view. It's a 3DX, not an MDL. It says it's under solid. So view solid. View solid. There we go. The requested module is not installed. Okay, so I don't have the module. Apparently it needs to be done with Carlson underground mining for whatever reason. So why they give you that option in takeoff? Let's do a command search. So convert, join utilities. All right, solid. See, all of these underground mining, I don't want to have that. Here's geology, civil, sections from 3D solids profile, consolidate, polysolid, underscore polysolid. My underscore polysolid. Nope. Oops. Why is it not underscore poly? Oh, that's why poly. Yeah, it's not part of it. All right, let's try file, import, a standard import. Do I have an MDL? Huh. Well, that's interesting. They let you create the model. I guess you can use it in other software. You can't use it in Carlson unless you have underground mining. Um, yeah, no commands for it here. I switch to my IntelliCAD menus. well, it's not worth trying to track it down to here. I don't know that we're going to find it very readily. All right, let me try my back to Carlson. All right. So that's basically one and the same thing. That's one of the reasons I like to just create the geometry myself because I can verify it, I can see it in relation to other things. I'm not stuck with just trying to define it as a line on the ground and letting the math be handled by the data that's attached to it. So it's just a preference of how you want that to work. Okay. A couple of other tools there. 2D to 3D polyline, that's the one that we use. It's under the Elevate. We do that all of the time, and we do it by a number of different tools. We did the line, the wall just now. We set the foot of the wall on the ground by a surface model. We set the parking lot curb elevations by text with a leader. Sometimes you can do it by simple text. If it doesn't have a leader, it just looks for text in the proximity of the point it's finding. It can be by slope from reference, which would be, it would read, say, a 3D edge and create a slope away from it at a given ratio, like a 4:1, just like these out here on this design pad template. We could have done a 2D to 3D by a slope away from that line, from some reference line that has elevation. We say set the elevation of this line based on that being a particular slope. So, and it doesn't have to be parallel to it. If I just draw a 2D polyline, let's just go like that. And if we take 2D by slope from reference, the reference is going to be a 3D polyline. I'll keep the, there's no need for that. I'll just say okay and select the polyline to assign elevations. Here it is. So I pick it and selected it. I don't hit enter to finish it, just pick it once. Now select the reference 3D polyline. So I'm going to take this back of curb line here as well. And now enter the slope percent. Well, let's say if we did it as, um, 4:1 would be a 25%. 1:1's 100%. So say a 25%, we'll make it negative 25%. Select the polyline sign elevations. We're right there, hit enter. So that's now a 3D polyline. So again, look at that one in its context. And you can see it took the back edge of the curb and it elevated that line by essentially creating a bunch of these little tie lines at 25% grade. So if I were to do this, um, I wonder if, I don't know that perpendicular is going to work here because it's, yeah, it's not. See, it's way down here because it's 3D. All right, so if I just, let me do some 2Ds. I'm going to go from here. I'm just going to eyeball that. Let's copy this. Dink to 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 dink. Get this one. We'll just move it here up to here. Now we're going to take this and we will extend this, 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 and this. That. Now right click and extend. There we go. That, 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 and that, and that. And this time we will trim. Okay. Now I would elevate those lines. So 2D to 3D, this time by screen entities, because this has already been set over here, this diagonal line. So I'm going to ignore zeros, that's fine. So now select the polylines to convert. They're going to be these. So I'm basically just doing this. Now you don't need to do this. I'm just using this to illustrate how it projected this based on the back of the curve. So those are lines I'm going to convert. Now select the polylines that I'm going to attach it to. So there they are. They're now created. So let's take a look at them. And now, just like we had on those green 4-to-1 side slopes off the back to where it went down and hit the existing ground, I've also got that 4-to-1 slope. So you can see what it did is it pushed that 4-to-1 slope from the back of my curb all the way down out here to set the elevation of that line there. Okay, so that's what that project by slope actually does for you. This 2D to 3D by slope from reference. Profile, again, just like we added to this wall, you basically give it points. You can also think of that as the same as this polyline elevation editor, same type of thing. Again, by text with leader, by start and end elevation. It could be all kinds of bins in it. You give it a starting elevation, ending elevation, and it evenly distributes the elevations all along that length, keeping the slope the same or constant as it goes from the beginning to the end. All right, then you've got a couple of other things here, and a lot of these are sort of self-explanatory. You got this pad polyline by interior text. So we had this building, we could have done that way. That's not a generally all that efficient command to do with this, but where that might be a good command is if you have a subdivision map with hundreds of little building footprints and they've all got that finished floor elevation label in them. You can use that command to establish the elevations of those lines. In fact, let's do this to illustrate that. Let's go to, just leave this file open if you'd like, and let's open another file. I think it's in our getting started. Yeah, that one called Civil Demo. There we go. Let's just open up Civil Demo. Oh, do we not have... Oh, I thought I had finished floor elevation labels in there. All right, never mind. They're already at elevation anyway. All right, let's do this. I'm going to isolate the buildings. I'm going to make all of those 0 elevations. So I'm going to elevate, set polyline to elevation 0. And there they are. They're now 2Ds down at 0. And I can restore. Let me get an idea of there's 840. And this goes up to, say, 837. So 840, 39, 38. So let's see. If we had text, we're going to draw some text. Just standard. We'll call it specify a start point. So right here, we're going to call it, its height will be just like that. We'll call it rotation will be east. And we'll say FF equal 41.5. And we'll make sure that's inside our closed polyline. Make sure these are all closed. They are. I'll now copy this and we'll change a couple numbers so you can see. We'll rotate that one. All right, so just a few of them. Now let's rotate this so it's all inside. And, all right, that was 41.5. We'll keep that one at 41.5. Let's make that 42. Make this one 41.85. 42.5. 42.75. You get the idea. So I'll make this one 843. All right. So now we've got a situation where we could have like this. It's all layer 0, these specific layers. If I call this layer, I'll make 2 layers. One say building dash FF LF. I'm going to just select all of these. Change that layer to FF elevation. These are on buildings. Okay. So let's even isolate those 2 layers. So now we've got that. So if we were to elevate 2D to 3D by text, but let's see. Pad polyline by interior text. There we go. Set the layer for the elevated lines. Sure, we'll call it Z pad. Keep the originals. Trim any polylines inside, no need. Offset the elevated polyline. Let's just go to the exterior just a wee little bit so we can just see the difference. And that's your one. Okay, so now select a layer sample of the text. So just pick one as a sample. Select a layer sample of the line work. We'll select that one. And it lets you choose another layer for samples of boundary line works, but that's all we need. We'll say okay, and now select everything you want to process. So we'll grab it all. And now you can see the ones that it read, and it stripped out the FF part, but it made those. You see how they're at those elevations. it didn't find any text in here. So what is this elevation? 843, 841.5, 842.75. You see it here in my properties. So a lot of times you'll have maps that have things like that with elevation labels inside them. And even if it's got other text like this FF equals, it just strips the numbers out and uses that to set the elevations there as a single sort of step. Okay, makes sense? So anyway, we won't go through um, selects text to elevate. All right, so if I elevated text, notice when I type these in, their elevation is at 0. See that text alignment and position Z is 0. But when I said elevate text, this has a position Z and text alignment Z of 841.5. So that is a real nice way. Let's say you've got a contour map and you've got all kinds of contour labels, but they're all drawn down at 0. And if you want to have them drawn at their indicated elevations, I tend to like mine that way. That command will do it. And that's the elevate text. Okay, and so you can basically just grab all of the text, everything it finds is text. It asks for the decimal symbol. So in our case, it's a period. We're not like a European country that uses um, the commas, for instance. And so now, when we look at this, you see all of that text has now been elevated up to be the same elevation as the building footprints because it read that text and put that text at that particular elevation. Here's that 842.75. You can see right there. A lot of these things are just common sense. They're fairly self-explanatory or at least readily apparent. And the best way in the world to learn them is just to sit down and get a file that you don't really care about if you mess it up and run through these commands. See what happens. You get these, you can set point elevations by a surface model or by a 3D polyline. You can sign these contour elevations. We did that earlier yesterday where we just struck a line across it and let it step up all of those things and it sets them all in order as it crossed those. Okay. So, just different tools to help you create the 3D geometry that you need to generate these models with. Now, surface is just like it is under civil, or not, it's not as full, but it's got some of the same. And this is to build those surfaces sort of discreetly or purposefully instead of as a um, just as part of that takeoff process where we just hit the build existing, build or make existing, make design. But this lets us do a little bit more finesse under the surface menu. And you can also, do these volumes by, the same report that we ran. You see that two triangulation surface volume, see that little icon? That's that same icon right there, the total volumes. Okay, and it says down below here, it tells you what it is. It's running a command called 10 volume. Same thing if I do it, where was I? Oh, volumes by triangulation right there. Now that's a different command. It uses the same icon, but it says the command down there is TRIVOL, so triangulation volume. And that's one where it's actually going to pick different surface files and run the computation. When we do it from here, it's specifically restricting itself to that existing versus design. That's part of takeoff. So I hope you can get a sense of what the construction module does for you is it sort of hides away some of that complexity with those models in the sense that you're basically telling it up front by a list of layers, hey, this is what makes existing, this is what makes design. Go out and do your thing, and then make these adjustments to those things, and then give me all the numbers, give me all the costs that's associated with that. And just a little more refinement on there, but you don't have to keep track of all the different things that you've added into the surfaces. Whereas when you do it the quote, the civil way, as opposed to, again, quote, the takeoff way or the construction module way, the civil way means you got to sort of keep track of all those different surface names and the data, the data that you used to build those surfaces. But again, you have a little bit more discrete control over that individual stuff. But you cannot assign materials to those surfaces other than in the takeoff layer assignments. You can set your source to that file that you finally made for the top surface, and then you can go and make the layer assignments with the materials so that it finds any closed polylines on those layers and uses them to apply the adjustment to those base level files that you've identified. But again, once you do that, it still makes those 6 surfaces. Same drawing file name dash OG dash EX dash BS dash FN dash ZE dash ZN. Okay. So all of those suffixed file names, those are still there. And that's the quote takeoff way that it's using to calculate that information, even though you might have those extra tools. So the surface menu gives you that. It also gives you some things like design pad template where we put those skirts around, and I'll close this back off. That's where we put these skirts around the outside because I wanted to see if I go to the back of the curb, where am I actually going to go out to if I tie that down to my existing ground? So at some point, you've got some limiting edges. They had simply drawn a little boundary that sort of followed around it. That could be okay. That could be all you're interested in. You don't care about that. You're going to say, well, the contractor knows how to dress that in. He'll fix it. Well, okay. And, I concede the point. That's fine. Sometimes we do it that way. But you have the tools right here with this design pad template to push that, or you can do it with elevate 2D to 3D by slope from reference. Or you can do it by edit polyline, 3D polyline utilities, offset 3D polyline. And this time you would do it by, not by interval, but to a surface. So you'd tell it as a target surface. That's the exact same thing as this design pad template. And again, all this extra stuff is doing is just giving you some verification to help you visualize what that's going to look like if you were to grade. If you were to build this site on this existing ground, you're going to have some cut areas in here. You can see right there, you've got to cut down. Now, would you actually do it that way? Probably not. You probably go to the back of the curve and then just shave this hilltop off flat, right? Maybe. Depends. Sometimes there would be a reason to do that, sometimes not. You know, maybe that's the edge of the right of way. You can't go past it. You know, there's all kinds of things that are not going to be exact necessarily, but our job as part of what we're doing here is to do that, is to actually create um, these models so that they are as precise and as accurate as we can make them, and that they reflect the original design intent. You know, if the design intent is to, let's say right up in here, instead of, you know, cutting down here and leaving this high, if the design intent is to knock this down, then, you know, my contention is the designers should have indicated that. See, right now it's just going, you see this brown contour that comes across here, that's this little elevated ridge. So, you know, we can cut this stuff into that existing ground, but then leave it out to here. Or is the better approach to go to the back of the curb and then just sort of push out flat till you know, get to this edge of, you know, the little edge of the hilltop there. And I suspect that's probably what they did. Um, Although that would have given us more cut to have to haul away. Mm. So, and the fact that we had actually, you know, you saw that that was an actually built project, so I don't really know how they did it. And I'm not 100% certain that the drawing that we have is necessarily from that project. This just came from, oh, excuse me, it came from Carlson as part of the examples files with the software. So, you know, take that for what that's worth, but we can also look at other existing files and how that process would work. Okay. So time for a good afternoon break at this point. Uh, Questions? Anything? Let me see. Let's finish talking about. So that was a takeoff menu. Then roads again is more for specifically road survey, specifically survey type works. Uh, Annotation, basically some draw things, some labels. Display is more specifically with their takeoff stuff or construction stuff. These express tools are actually an add-on to the CAD software. It's not part of Carlson at all. And that's really the the essence of that whole system. Okay. So again, let's go ahead and take our break. We'll come back at 3:20. I'll give you that 15 minutes plus a couple. And then we'll spend the rest of our time. I'll answer any questions you might have or show you some other examples, some different things that we can look at. Maybe we'll load up some of those other files, like those Guardian files, and see how that works with some some actual data files that, you know, instead of this little sample. Okay. So let's see you back here at 3:20. I will stop my share and I will pause the recording. Doomed. Okie doke. So hopefully you've seen not just the little tutorial that you see in this book, which is also the one that you can see on the help menu, this Carlson manual, tutorials, uh, takeoff, takeoff site net from start to finish. This is, I mean, where they do a couple of things correctly. I'm trying to get a sense of that. Yeah, see, they've got that set to a different elevation. anyway, um, what what this does, oh, there you go. There's the Google Earth image that they show underneath it. And so, and this basically follows this same process, but they don't really do all of the nuances that you really get into. They show you the basics and then leave you sort of on your own to try to figure the rest of that stuff out. Um, Let me see what else they've got done here. Oh, that actually was not, this picture was not what I did, but this was where they took their data and they exported it out to Google Earth as a KML. Um, all right, so anyway, you've not only you've learned the basic process here, making the two sets of files, but you've learned a couple of little uh, extra nuances, like how do you tie that back down? Don't just leave it hanging out there in the middle of the air, which is what they do in that tutorial. They don't show you how to fix problems like with this banker. They just assume everything's correct. And to be fair, a lot of that stuff is done and is ignored and is safely ignored, really, by a lot of contractors. So this software is sort of marketed toward, it's aimed at contractors. And so they basically say, well, they'll know how to tie that into the ground. All right, and they'll do all that as part of their work. And that's true. It will. But if you want to get more exact and more precise about this stuff, these are some of those extra techniques that you can use that we've been looking at. So, with that, were you able to think of any particulars that you might want to take a look at? Or do you want to look at some of those other files that we worked on that are included in your data set? So it'll take some time and practice. Yep, that's exactly right. Fine tune the model to make it work well on the machines. Yeah, that's a very good approach and an attitude. I will ask you while we're here as part of class, do you have um, a smallish site, some drawing files? Do you have something that you might want to take a look at together as part of class here in the last hour? You can just email me the drawing file and we could step through and see if, see what that approach might be. The same to look at. If you had something you might want to take a look at, or if you don't have access to that kind of stuff, that's fine too. You may be taking the training, from home or something. I don't know. Uh, I will ask you too. I looked up where you're working. I see you're close to Greenville, I believe, in South Carolina, if I'm not mistaken. Um, and I may have told you this back in the last class, but I used to have, they're all dead and gone now, but it was my dad's aunt and uncle, so my great aunt and uncle, um, and their two sons. They had twin sons named Tom and Jerry, and they lived right in Greenville proper. Lived there, gosh, 70 years. They had the house between the two generations. So we actually went down and visited them once, but okay, so nothing small you're working on, 30 plus acres. Wow. 100 lots on it. Okay. Yeah, you're close to Greenville. So, yeah, so that's basically, and the difference here between this little lot and say a 30-acre lot, 100 parcel project is just a matter of scale, so you could do that all as one, or you could even partition it off as, phase one, phase two, or lot and block. And you can do that a number of different ways. Maybe talk about some of that. So let's uh let's open up another file. Let's see. I think we'll get tired of this one. Let's open up, let's see what else we've got in our getting started. We've got let's open up this sample from T3 Global. Now this happens to be a single site. You probably looked at that one in Civil as well. But here, and I'm going to close off these toolbars now. We're not going to I'm not going to go through the whole process with this necessarily. Well, yeah, maybe we will. But what we have here, let's say if this were much larger than what you're working on this 30 plus site, but maybe you're only working on an area up in here, that might have been, say, there's your phase one. You're going to work on that and get it done. Then you're going to go to these other areas of the site. So one thing you can do to really help speed up your work is if you're working on this particular part of this area, you can take the big overall total drawing, do a save as, and you would call that something like phase one or whatever you're looking at. And if this is the area that you're restricted to with all of that work and you're going to do that first, well, just go to your edit menu and choose erase by close polyline. Then you would select that polyline, tell it the things you want to erase. We'll have them all checked and we're going to erase outside and we'll say okay. And then what you're left with, then you can just throw that line away if you want. So now you've got a much smaller set of data to try to work with. So your calculations will go a little faster and you can get that stuff done. Just be sure if you do something like that, that save the original that you can go back to and get the remaining phases. Now, what happens when you get that part all done for this, and then you go to the next one? Let's say you need to, merge some of these surfaces from this work into the other work. Well, those are in your surface triangulation file utilities, where you can load up, a basic file, which I don't have one here. Uh, this is for a completely different drawing, but you could you load up that one, say from phase one, then you go to the next button, and I'll turn this back on. Then you could merge a 10, and we'll merge, what did we have? I think that fits this site. No, must not have been. come on. Yeah, I was picking surfaces that aren't really related. So I think I've sort of broken it. Great. Adding inclusion, exclusion polylines, which we didn't have any. Yeah, but anyway, let's let me kill this thing, go back to it. Sorry about that. Carlson, end task. I'll come back. But anyway, little tricks like that that you can do um, to help speed things up. So just, sort of get a sense of how to organize and break this stuff out and do your practice, lay these things out. So let's go ahead and we're going to practice on this sample from T3 Global. Now, I don't know if you remember going through this in civil, where we looked at building the surfaces for this. Again, and in that case, we didn't use that takeoff stuff. We just did the, um, built the existing, built the proposed, although there's not really a proposed design here. This is just an existing conditions map. And we could use this same thing for that. Now we've got a number of things. You might be tempted to use these contours to set, and by the way, everything is elevated already. So you see the contours are elevated, but there's all these little break lines that are elevated as well. And if you recall, if you did this exercise in that class, I don't recall if we did necessarily, but we usually do this in fundamentals. But we also often do this in civil, where we looked at what makes this as a surface. So if I do something like here, now these particular white lines, these are in a layer called V topo break line. So those are all the break line data. I've also got a number of points down in here that you can't really see unless we go to settings, IntelliCAD settings, point style, and let's turn our points on to be something that you can see, these little dots. So I've got a bunch of points. Now they're on a layer called VTopo DTMP. Now that's really, if I were to isolate that layer and this break line layer and look at that in my 3D viewer, that's all in the world you need to build that surface and build it pretty much exactly like they did. But you might be tempted to, I'm going to restore my layers now, to use these contour layers as your existing surface. And so the difference between those two, let's go ahead and do that. First, we're going to need a boundary around everything. So let's just draw a boundary, or let's draw shrink wrap entities. We need to say across gaps because we don't have that bounded line work like we did before. We're just going to go around the ends. And we'll do a perimeter reduction of a medium, and let's make it a 2D. We'll put it on this layer called C Topo Surf Boundary. We'll say okay. We'll grab our data. And there we go. We've got a boundary. We're not going to worry about straightening up the edges. We'll just leave it at that. Okay. So our first step now in here is we're going to create this, set the boundary polyline. So there it is. Now we need to assign existings and designs and others. So right now we've only got existing, so that's fine. So let's assign existing right here. So we're going to pick layers for existing. And I'm going to come down here and my first, reaction will be to set with these contours. So I'll get one of the index, one of the intermediates, and I would go over here and get one of these obscured index and obscured intermediates. And that now is my existing. Now I don't have my colors on. Everything's elevated. I'm going to leave them like they are. And so if I turn off other, remember everything else is other because right now the only thing I've set, if I look at my define, is I've defined those layers to be my existing. I don't have anything in design. Everything else is in other. So I've turned off other, and this is now my design. Now you can leave those on. You don't have to turn that off. But if I then make my existing ground, all right, so here I did, it's made, everything worked, right? But let's look at that surface. So I'm going to choose that surface viewer. I'm going to look at the original ground, say okay. And I look at this and I see, well, I've got my ponds over there. They're looking okay. But I've got this mess right in here. And that's because those contours had been trimmed. And I've also got a situation here along the road edges, although that one actually worked okay because I told it to minimize flats. So that edge worked okay, but this edge over here didn't really. So these flat edges don't really exist. So that's using the contours. And sometimes, really, honestly, that's okay to use the contours because really you're after bulk materials and bulk volumes, that kind of stuff. That may be all right. However, let's go back to our, we'll turn our other back on. And let's go back to defining our surface manager here, our layer assignments. I'm going to take these contours now and I'm going to put them back under other. Okay, and I'll save and exit. And now with everything showing, instead of using those contours, I'm going to use these break lines and points. So I'm going to set that for existing. So I'll choose that set. So I'm going to pick one of those and I'll pick one of those points. I'll say, okay. Now, when I look at my definitions, under existing, I've got the break lines and the DTMP, the digital train model point. That's what that stands for. I'll save that and exit. And now I'll make the existing. It goes through and does the same thing. I've got a couple of little crossing areas because they've got a little head wall area that's messed up. We're going to just turn that off and ignore it for now. But normally we'd straighten that out. Now I can turn off my other, and you see this is what's left for my existing. So now let's view that file and look at the difference. So now you remember that mess over in here. See, that really is a retaining wall or a loading dock on that building. But look how nicely well-defined our curbs are. Our streets. Over here's another retaining wall up here on this part of the road over across the street. And if I look down at my road edge, you see all those flats got eliminated because everything was treated as brake lines. So that's really a much more accurate existing ground. Right in here is where that little head wall was messed up. So it sort of fizzled in there. Um, so, we can use that to generate those surfaces and do everything like we did in the class, except we did that under surface, triangulate, and contour, and we went through all of these different things. But you can see how takeoff or the construction module can help you really just tell it what layer it's on and let it do the work. And you're not really needing to worry about that. And so if we say, let's hide the existing, so that's going to turn those off. Let's turn the other back on. And now let's see, these are 1 foot intervals. I think that's 1310. That's 1311. 1 foot intervals. So let's draw. Let's go to our display over here now. And under the existing, let's turn on the existing contours, but let's go to the contours and set the settings for it. So we'll take these layer names. We won't label them. Let's go to the color or to contour. We're going to layer by interval. Let's set our contour interval to 1 to match. So our index will be by 5, 1. And put a little smoothing on if you'd like. And we'll say OK. And say OK. And now we're going to display, go back here to the contours. That's where we did the settings. We do the display setup. Now let's draw these existing contours. And when we do that, you're going to see them. They're going to draw over top of the ones that they had. And you can see how ours are nearly exact. You got a couple of little, tweaks in here where the contour smoothing might have, missed a corner or something. But you see how those are almost exactly the same as what they provided. Here's another example of where the smoothing was slightly different. If we actually go back to our settings, contours, existing, let's turn off the smoothing, say OK and say OK, and then let it redraw. And well, there's still, a little localized, little slight differences. Okay. So that's a good validation on using those break lines and those points to help define the surface, because that's what they did. I'm going to go back to my display now and turn that off. So that's what they did when they generated these drawn contours. They only used the break lines and the points to create the contours, and then they delivered that file. But they also delivered the break lines and the points in case you need to rebuild the surface. Okay. So compare that now with the difference that you see is if we go back to our definition, we take these two layers out, move them back to other, and save and exit. And now let's pick the contours again like we had before. This one, one here, one here. Okay, so that's now done. I'll turn other off. I'll turn existing on. So it's just the contours. And now if I make existing, it's going to be that one with the goofy stuff in it again, up here and along the road and with no curbs. And if let's view that. Yeah, see, there's got all that mess over here. And you see, there's no curb definition to speak of because the contours don't really help to define that. So to look at the difference now in those surfaces, let's turn on these existing contours and see how far you've missed the ones they drew. These are all of ours in here. See, they don't have anything out there. They've got this one, and then they've got this one. And they've got a retaining wall drawn in here. If I turn the other back on, see, they've got this right here. That's your retaining wall. But you see, our contours are all over the map in here. They don't recognize that as a wall because we didn't use it as break lines like we did before. All of these curb lines we used as break lines, so that's what set those curb definitions. But when we only use the contours, so you can see now, let's draw the contours back. There's our contours, so you can see we really got some differences here. We actually managed, see, do we have, there's our existing contours. What are they? And the contours actually match not too terribly bad in here, but the surface itself. So our contours overlay pretty nicely, except for places like that and in here. But the surface, even though our contours look the same through here as theirs do, but the surface itself, when we view it, we've got all these little convoluted jumps in here. That's not enough to trigger the contour change. It just happened to luck out in that regard. And you got some generalized sameness, but you can't really see, you can see a little bit of the curb in there, but you can't really tell where those things are. So, instead of always jumping in and grabbing existing contours to define your existing surface, and even your design surface, if your design surface shows a bunch of drawn contours, and if that's really all you've got, well, that's all you've got and it's what you need to use. But quite often you'll see things drawn with indication like spot elevations along the curbs and building floors. So that's really what you want to use because it treats those as break lines and sets those things up so that the contours will fall out of that picture. They'll generate from that data, and you don't need to include them unless that's all you have that sets the definition. Okay? So again, just use your noodle. We'll turn that off. Turn the other back on. There, we're back to the original. There's our little boundary. And we'll turn to get rid of that. So that's now that particular file. Now, you could have set these building outlines as exclusion areas, in which case you would have gone to, there's not really anything you can do with it this way. You could, and let's see, you could set exclusion polylines, and that would be those building outlines. So if we set some exclusion polylines, and I'll grab these building outlines, you'll see what this is going to do. There's three, here's one down here. One tail run right here, there we go. So there now has been set for exclusions. I'm going to go back to my build and take these back out, move them back to other, save, exit. I'll now go in here and pick the break lines and the points, and we'll now make existing. Oops. Let's see. Speaking of oops, there it is. So because we have to leave it in if we're going to use it. So boundary polyline, set the boundary polyline. There it is. We've got the exclusions already set. Let's make the existing. Ignore those errors for now. And then view this surface, and you're going to see, because we had those exclusion areas, you see it just basically cuts a hole in the ground. It doesn't know what's underneath those buildings. Sometimes you do it that way, sometimes you don't. Let's say if you have a pond surface, you don't know what the ground looks like underneath the water, so you would maybe clip that out as a exclusion. In the case of building footprints, well, you can, depending on what you're doing and what your purpose is, and again, there we see our curbs coming in nicely. Depending on what the purpose is, we may want to just assume that the ground is flat under the building, so we wouldn't necessarily set those up as exclusion areas. Okay, so we would just let it calculate across the floor space. Okay, so again, use your noggin. Try to make sure you understand what it is you're after, and set the data up accordingly. Now you've got all of those different areas. You can take a look at them like that. You can look at them with this quick profile, for instance. If we just go across our ponds, there you can see I've got that big valley pond here. And then right in here, I've got that little perched pond that sits up here on that shelf before it dumps down in here to this little natural gully. Okay. And again, adjust the alignment. You can click, and as you move along, you're going to see it update itself in real time. Okay. So with that, as another means of very quickly jumping into things, again, the first thing to do any type of new work is to sort of analyze what it is you have on your computer, on their screen. Do you have something that if you've got these layers and these drawn figures and they're drawn as break lines, that's my first rule of thumb, is if I see that I've got break lines and spot elevations that I can use, I would isolate those layers, see if it's going to give me my definition that I want by viewing everything in 3D with my just regular 3D viewer. And I look at that and I say, wow, that would really define that surface. I can see right over here's that retaining wall edge. You can see at that loading dock. I've got all of these features over here, which were there's that retaining wall across the top, and then the curb down at the bottom. So you see, I can really verify that and see that, well, that would be what I would use. And then I would simply say, well, that's what I want to use to create my existing ground. And I wouldn't even worry about trying to use these contours. Now, if you try to use them both, you're going to get all kinds of little crossing errors where they crisscross each other because they're not allowed to cross. The break line data now, down in here's that the head wall where they do cross. So I get a crossing error right there and a crossing error right here. And they basically did the same thing. They ignored it and just flew past it and delivered the file. So, you can go to set about fixing that if you wanted. If that was crucial for you, you can either try to fix it based on some relative elevations, tell which one's the top, which is the bottom. Sometimes you have to send a crew back out to go out and resurvey that particular feature. And then you would just bring it back in, edit the data, rebuild the surface, and away you go. Now, again, no design on this, so there's no real way to get any kind of volumes and reports and stuff. And so all I did was use it to generate my existing conditions. And you can see very quickly it does it that way. Whereas when you do it this way, triangulate and contour, you set all this up, you tell it to use an inclusion area, yes or no, and whether you want to draw contours and label it and do all of the different stuff. And then it's going to ask you to pick all this stuff, and you go out here and you select the data, and you have to give it a named file name. But if we look at our surface viewer within our, now we're going to see a bunch of these called sample from T3 global. There's your -EX, -OG, and -ZE. So it made those three samples for, or those three terrain models for my existing ground. Okay. Let's see, what else might you want to take a look at? Does your company do its own survey work? Or again, you're probably, for, if I recall, you're taking people's files that they send you and working on that stuff. Is that correct? Or do you ever go out? Of course, you being a drone pilot, I guess maybe. Um, if you come in with your drone data to uh, create some of this stuff. And that's a whole different ball game. In fact, we don't even have the software that's best to do it. In that case, we would use, uh, either point cloud. Carlson has a point cloud menu, and I don't. The legacy engine support has been discontinued. Carlson point cloud continuing. That's right. Huh. I guess the new version, it won't let me run it. Well, I guess it will. It still does. It just uses a different computation engine. So this is where you can set up all your point clouds, and you can have it, extract features and generate service. But that's an entirely different process. Use a different software for your drone surveys. Yep, that's generally the case. Now, once you have that done, and if you've generated a surface model, then you can just simply use that. You would set up your layer definition under existing and change it from layers to file. Select the file and go out there and find the file. Now, you won't find a file in Carlson format. You might have to import, say, a Civil 3D file or a 1,2D file or something there, or under, let me switch back to under Surface. You can import some of these different file formats. The universal one that everybody should be using typically would be available under the file menu, import, under land XML. That's sort of the lingua franca for all of those different software. So from your from your drone software, if you generate a terrain model as part of that process, then you want to look in that software and create and export a land XML file that brings that surface data across. And then again, assign that as an XML file. You go to Carlson, pull down file, import land XML file, pick that file they gave you from the other software. It creates a Carlson format file, and then go into that layer definition and point it to a file instead of by layer designation. And then again, you would still have to go here and make existing, even though it's reading that other file, and then it makes those three existing surfaces, one as is, one with any zones that you might have, any subgrade zones, and then one with topsoil applied, topsoil stripping. So those would be some techniques to sort of keep your eyes open for on getting some of this data done in your particular workflows. Okay. Um, anything else that you want to think of? And I will, let me give you this choice since you've been so quiet and behaved yourself so well in class. Um, we can, if you like, go ahead and knock off a half hour early if you'd like to do that. It being Friday and it's probably, old beer 30 somewhere. Um, I'd be glad to do that. Or if you got anything else you want to look at, let me know and we can wrap that up. Otherwise, we've pretty well covered everything we need. But anything at all that you were looking toward doing. Okay, so you're all good. I will leave you with that. You'll have the videos. I'll send you your certificate with your PDHs and with, they say, working on tuning the models. Very good. Exactly what you need to be doing. And again, use those visuals. Use those tools to visualize this stuff. Like I said, these toolbars make it really handy. Um, but if you choose the regular viewer like View, 3D View, Surface File Viewer, then you have to, go in here and find the named file that it generated. But if you do it with this viewer or under Take Off Graphic Reports, and come down here and choose Surface, then that lets you pick. And when you do that, it's, in this case, all we've done is original ground. If we had done design, you would see those other choices like we saw in the other file as well. And you can choose which of those six that you want to look at. And it loads it all up in the viewer and everything's just as if you did it manually with these other tools. Okay. So with that, I will let us call it a day. I will, like I said, I'll post the videos up to my YouTube channel and send you the links to those along with your certificate. It might be the first part of the week before you get those done because it takes a little while to process the videos once they go up to YouTube. Um, but I'll send those along the way for you and you'll have those. And again, you've got my email, which also includes my phone number. Any questions, please feel free to get in touch. Because that, again, that's part of what you get when you sign up to take a class with MSoft. You get access to us as a resource. So um, use that when and where you need. All right. So if you're all good, I will wish you a grand end of the day for a Friday. I'll stop my share. I will stop the recording if I can. It's up here at the top now. There we go. Stop the recording.